Right. So guys, let me just hear, where are you all with bearings? Let me hear. How will you feel about bearings? I need to like get an estimate of where you all at in bearings.
Good night, sir.
Good night, Ivan. What's the plan? You good?
Yes, sir. Yes, sir. I think so.
Okay. So like on a
I
scale of one,
think so.
honestly, I don't get the man wrong, eh? Don't get the man wrong for saying that. All right. So when I mentioned the word bearings, how are you feeling? Are you feeling like this? Are you feeling like this? How are you feeling about bearings? Oh, don't be scared to talk and think. This class is real vibes.
I think they go understand if they see the workload.
I
Like
think so.
if they see it first, they go be like, "Oh shucks, this looking like heaviness."
Well, we go see, right?
Uh,
We go see. So here this.
yeah.
These classes are extremely interactive. If you go and stay quiet, you're probably not going to benefit. So I need a volunteer. Who's going to volunteer to start us off? I need a brave soul here. Kelly, you ever do bearings as yet?
No, sir. No.
Oh, you go with directions?
No, sir. No.
Oh, oh shucks. But okay, do you know the difference between clockwise and anti-clockwise?
Well, clockwise is on the going right, anti-clockwise is on the going left.
Um, I would not think about it like that, but I guess you could think about it like that. So here what, Kelly, let me give it a shot, right? So when we talk about bearings, we are talking about direction. That's what we're talking about. So bearings is just simply direction. So in other words, how would I go from one point to the other point? So Kaylee, let me just say you over here, right? And give me your friend name. You have a friend?
Sir.
It would be pretty depressing if you didn't have a friend. Um,
No, I have a friend. I have a friend. I have a friend.
you give me the name of your friend. Did you just put
Soraya.
Soraya? Okay, I'll put Soraya over here.
All right.
So I'm gonna call this point K, and I'm gonna call this point S. Now I'm gonna connect these points. So let's just say we wanted to go from by you to your friend. And it would be useful if we knew the direction.
Yeah.
Yeah. So when we're doing bearings, we always take it with respect to the north line. So we're starting from by you. So starting from by you. So from you, I'm gonna draw a north line. I'm gonna put on a north line over here. And you know, like north, south, east, and west.
Yeah, I know the basic directions.
Okay, great.
Right.
Let me just put it down here for anybody that didn't know. Right? So this is north. Guys, what is this? What's that? Somebody tell me.
So,
Yeah, that's south. That's south. What's this? What's that?
But I don't know, boy.
that's west.
This west. And how I just remember it is north, we, S. Right? We. So this is east. North, south, east, and west. Great. But the main one you
I
have to
never
do
knew that, you know. I never knew that was.
is a goated hack, right? We. You will never forget it now, right? We. Any geography
Nah,
student, they go remember.
I guarantee I remember. I don't know for sure was. I mean, I remember that none. And any man asks me for direction, and I'm pointing them north instead of south. No.
Oh, you're getting people them lost, boy.
Just point out this. If you ask me for direction, I don't know west from east, from south, from north, from nothing. But you're asking for nothing. You are going north, you're going east. Just
Don't,
point out.
don't, don't ask me. Yeah, I only know directions on paper, not in real life, right? Let me ask somebody. Let me ask somebody. Camille, I see you here, right? Camille, do you know your basic directions?
Yes, sir.
Yeah. Okay, great. I want you to tell me which one is clockwise, which one is anti-clockwise. One or two? Which one is anti-clockwise?
Um, The arrows pointing the same way to me. Wait. One is clockwise
Right?
and two is anti-clockwise.
All right. Do the rest of you all agree with this? Saying that one is clockwise, two is anti-clockwise. Adika, let me know if you agree with that. We're saying one is clockwise, and we say two is anti-clockwise.
Yeah, I agree with that.
Okay, great. You need to know this. Somebody had a mic unmuted and I'm hearing some people. Uh, all right. So whenever we're measuring bearings, it's always from the north line, in a clockwise direction, right, to the line joining the 2 points. Right, so Keely, we starting off from by you, right? And we're going to go by the north line. Tell me, Keely, if I'm measuring bearings in a clockwise direction, will I measure it like this? Yeah or no?
No, that is anti-clockwise.
So guys, this is a big mistake students make. They try to measure bearings like that. This is wrong. This is very, very wrong. Don't do that, right? Don't do that. Otherwise, I'll even make more look like this. Don't do that, right? The proper thing to do is measure the angle in this direction. So Keely, you see how we started from the north line and we went in a clockwise direction until we touched the line joining you to your friend?
Yes.
That's a bearing.
Okay.
Make an estimate. What kind of angle you think this looking like? What kind of angle you think that looking like?
Like acute angle.
It's definitely looking less than 90. So give me an angle. Give me an angle.
Mm, mm, like 63 degrees.
All right, 62 degrees. Okay, great. Now, we just figured out the bearing from by you to your friend, 62 degrees. What if we wanted to figure out the bearing from by your friend to you? That's the question. So let's make that a second question, right? So guys, so far, we understand that bearings is measured with respect to what? What was this called? Let's do a quick recap before we move forward. What was this called?
From the starting point, sir, if I'm not being mistaken.
From the starting point, yes. It's always measured with respect to the what? Well, what do we call this line here? Anybody can give it a shot. What do we call that line?
Direction. Direction.
No, we call that the north line. So we always measure the angle
Okay, no time.
in a clockwise direction with respect to the north line. Always. Always, right? So just a little recap for when you're doing bearings. If you see the word from, guys, if you see the word from, that's where you're starting from. This is your starting position. Starting position. At your starting position, you're going to put on an outline. Put down a note line. I'm curious, any other taking notes though? I'm just curious.
Yes.
Okay, great. Right. From the note line, draw an angle in a clockwise direction till it touches the line connecting the 2 points. Right. This is the main things you need to know when dealing with bearings. some other things. Priscilla, say that.
Yes, sir.
All right. Some other things you need to know, right? Priscilla, what is the sum of angles along a line? Selma, if you have a line, you just have a line, right? What is the sum of angles about a line?
180.
180. All you agree with that? Let me know if all you agree with that. The sum of angles about a line. 180.
Yes, sir.
Yeah, that's correct, right? Now, when you're doing bearings, you're going to see the lines looking sort of like this. A bit different, but it's the same concept. The angle over here and the angle over here must add up to 180 degrees. So I could call this angle 1, right? Theta 1. I could call this theta 2, right? The point is theta 1 plus theta 2 must be equal to 180 degrees. That's something you need to know. Another thing you need to know is the sum of angles. Right? Sum of angles for a circle. Could anybody tell me the sum of angles for a circle? What is the sum of angles for a circle add up to?
Circle 360 degrees.
Yes, 360 degrees. Right, so guys, take a screenshot of this, or take a screenshot, and we're gonna move on, right? Take a screenshot, we're gonna move on. These are the main things you need to know when dealing with bearings. This is the foundation. Right? Do you all have a screenshot? Let me know.
Not as yet, sir.
All right.
Yes, sir.
Okay, Darius, that's you?
Yes, sir.
Okay, nice. Guys, take a screenshot, right? And I hear it from the rest of you guys. I tell you, this is real interactive, eh? These sessions real interactive. I'm gonna call somebody random that never meet before. Makiba, how are you? Are you okay? I see you unmute, but in here. Okay, I'm not hearing you. What about somebody else? I see somebody join whose name starts with S. I don't know who that is though. S. All right, tough crowd, tough crowd. But let's move on. I'll have a screenshot of this.
Yep.
All right, great. Let's move on. So the question was now, what is the bearing? What is the bearing of Keely from, I'm gonna butcher this spelling, eh? I don't teach English, I teach maths. So don't come for me. Soraya. I spelled that so bad.
Oh, there.
Wait. I try a thing, right? Don't come for me. So, Keely, if I want to figure out the bearing of Keely from Soraya, where am I gonna look at? Where do you think I'm starting from? Based on this sentence, where should I start from?
From your starting point.
What's the starting point this time? Where you seeing the from by? It's
Soraya.
from Soraya, right? If I'm saying from Soraya, doesn't that mean I'm by Soraya right now?
Yeah.
Yes. Right. So from Soraya means that I am by Soraya. And who do I want to go by? Who do I want to go by? Tell me, Keely, who do we want to go by? According to this, who do we want to go by? So we buy Soraya and we want to go to?
Me?
Yeah, we're gonna go to you. So the first step, we're gonna put on a note line by Soraya. That's the first thing we're gonna do. We're gonna put on a note line here. When I'm measuring the bearing, remind me, I'm starting from the note line and I'm going on a clockwise or anti-clockwise direction. Remind me, clockwise or anti-clockwise?
Clockwise.
So will I be doing this? Is that the bearing?
No.
No, that's not the bearing. If you do that, don't do that. Let's just say don't do that, right? Guys, don't do that. This is the answer for this question. So, don't know how good notes do that, but this is the answer. So, Kaylee, can you see we are by you because it said from Soraya. We went in a clockwise direction and we ended up touching the line connecting you to connecting Soraya to you. Seeing that?
Yeah.
Okay, great. Guys, are we on the same page so far? Is anybody lost? Tell me. I'm very patient when it comes to maths. Is anybody lost? Perseus, are you lost?
So, sir,
Tell me, Ivan.
clockwise is like going forward.
No, imagine you have a clock, right? Imagine you have a clock. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. Let me just say we have a clock, right? How would the clock go? Wouldn't it go in this direction? Would any clock go in this direction? Yes or no, Ivan?
Yes, sir.
Yeah, that's what we mean by clockwise. The same manner in which a clock moves. So when I say clockwise, I'm talking about imagine a clock. I know everybody here real young, right? I cannot old. I'm really not that old. But most of you are accustomed with digital watches. But analog watches would go in a clockwise direction starting from 12 and make a revolution. So Ivan, when I talk about clockwise, is what I'm talking about, right? This direction. Understand?
All right.
Yeah. Imagine a clock. Great. So let me call somebody. Adika, are you there?
Yeah.
All right, Adika. We want to figure out this angle over here. Now looking hard or looking easy?
I don't know.
It could be real honest. To be real honest. If you're kind of confused, you can tell me you're kind of confused. It's all right.
Maybe.
Maybe, all right. Do you understand that we wanted to go from Soraya to Kaylee? So we want to go, look at the question. What is the bearing of Kaylee from Soraya? It means that we started from Soraya and we want to go to Kaylee. You understand that much so far?
Yeah.
So we're from Soraya. The bearing is the angle from the north line in a clockwise direction until it touches the line connecting the two of them. So that's the bearing over there. You understand that?
Yeah.
All right. So the question is, how are we going to figure out this angle? Now you would have seen that I said earlier, the sum of angles along a line is 180 degrees. So Adika, I said that if you have two angles, right? And this is our north line and this is our north line, then the sum of angles needs to be 180 degrees. So let me show you how we could figure this question out, Adika. If we know that this angle here is 62 degrees, then this angle here, we think this angle is supposed to be
180 minus 62.
exactly right, 180 minus 62. I like how you're thinking. So what is 180 minus 62? 180 minus 62.
118.
So 180 minus 62.
118.
118. So let me show you why that's good information to know. If we know that this angle here is 118 degrees, remind me, guys, what is the sum of angles for a circle? Tell me, I forget. I have the memory of a goldfish. Could somebody remind me what the sum of angles for a circle?
360.
360. So if this angle is 118 and the whole thing is supposed to be 360, how would I figure out this missing angle over here? How would I do that?
Minus the 360 minus the 118 from the 360.
Correct.
Yeah?
Uh,
And
Yeah,
the
yeah.
answer would be 242.
Yep, that's correct. That is correct.
242 degrees.
So you'd say 360 degrees minus 180 degrees. And that would be equal to, it's at 242, right? 242, that's the correct answer. So the answer is 242. So I'd like to recap everything that we did thus far. I don't like to rush. I like to make sure we're going at a reasonable pace so nobody is confused. Shayna, you there?
Yes, sir.
All right, so Shayna, in this question, let's examine what they said. They wanted us to figure out the bearing of Kila from Soraya. So where do we start off at?
Kila. No, sorry.
Right. If you see the word from, that's where you're starting off at. From is where you're starting at. So we at Soraya, right? And who do we want to go to?
Keely.
I want to go to Kili. I want to go to Kili. Now, to do that, we need to figure out the angle. Now, Shina, when we're measuring the angle, is it clockwise or anti-clockwise?
Clockwise.
Right, so we start from the north line and we go and go and go until it touches the line connecting Kayla to Soraya. Understand?
Yes, sir.
Right. We knew that this was 62, and we also know that the sum of angles about a straight line is supposed to be 180, yeah?
Yes, sir.
If this is 62, you understand how we figured out that was 180?
Yes, sir.
Okay. And if this is 118, remember, what's the sum of angles about a circle?
360 degrees.
Correct. So 360 minus 118 give us 242. That's it.
Yes, sir.
Right, that hard or that easy?
That easy.
Guys, we just now mash up a good bit of bearings, you know. Is the whole concept of bearings. Once you understand this, you're locked in. Right?
Yes, sir.
Right. Wait, no, that was the wrong meme. Correct one. Right. So we just now mash up bearings. If you're still confused, let me know, right? Who to call on, boy? I feel like one or they're confused. I have a sense, I have a feeling. Kaylee, you confused by anything?
No, I understand it.
All right, Adika, do you understand everything?
Yeah, I understand it.
Okay, so Darius, what about you? Let me know, Darius. Did you understand it?
Yes, sir. So far, I understand.
Okay, well, let's look at a fresh question now. All right, so who wants to help me with this question? Let me hear. Do I have any volunteers? I promise, guys, I don't bite. I don't bite. Promise. I don't bite. How will I leave them hanging here like cliffhanger, boy? Please, boy.
All right, so let me go, sir.
Yeah, Darius, let me go, right? So, Darius, give the question I read for me.
Right. Number one, the bearing of point C from A, point D is 85 degrees. State the bearing of D from C.
All right. So, Darius, forget about that second sentence. Let's look at the first sentence first. Read it back one more time for me. One more time.
The bearing of point C from a point D is 85 degrees.
Great. So, where are you seeing the word from? From will tell us where to start at.
From D.
Right. Notice they're saying from a point D. Right? They said from a point D. We are starting at D. Starting at D. Right. So we're going to put down a point and we're going to call that point D. Darius, you understand everything I'm doing so far?
Yes, sir.
All right. And they said that the bearing of point C from point D is 85. So let me show you how we're going to do this. We're going to draw a north line by D. We're going to draw a north line by D. All right. And what was the bearing? Darius, what was the bearing?
85 degrees.
Right. So 85 degrees might be, this is 90, so I guess we could say that. You okay with that?
Yes, sir.
All right. And that bearing would take us to what point?
C.
Exactly. You getting it? That's what we're talking about, right?
Yes, sir.
All right. Kaylee, did you understand what I just did? It wasn't magic or anything, right? You understand that?
No, understand, sir.
Okay, good, good. Um, Adika, Camille, Ivan, Perseus, Sheena, are they understand?
Yes, sir.
Yes, sir.
I understand.
Good. Right. So in these kind of questions, I'd recommend that you put on a base layer first, right? So interpret the first sentence and put it down. So Darius, let's look at the second part of the sentence now. What are they saying?
State the bearing of D from C.
Where are you seeing the word from? Where are you seeing?
C.
So where
So
should
we're
we?
starting at C.
Exactly. Starting at C. We starting at C, right?
Yes, sir.
So I'm gonna put down a note line. That's the usual procedure. You put on a note line first. All right. And we want to go from C to where?
To D in a clockwise direction.
Right. So tell me, is this correct?
No, sir.
No, that is not correct. Don't do that, guys. This is clockwise. That's clockwise. And is the wise answer as well. Right. So that's what we want to figure out, Darius. Yeah?
Yes, sir.
Okay. Now, you can think of this as a straight line. And if we know that this is 85 degrees, what do you think this angle would be?
85, well, 180 minus 85,
Right. 180 minus 85. What is
95.
Yes. 180 minus 85 degrees, that would be equal to 95 degrees. So tell me, Darius, if we know that this portion is 95 degrees, and we know that for a circle is 360, how am I going to figure out the missing piece?
We had a minus 95 from 360 degrees.
Yeah, minus 95 from 360. And do some mental maths here. You think you could do that mental maths?
265.
265. Yeah, that's all incorrect. 265. So 360 minus 95 degrees, 265. Is there anybody that did not understand that? So the answer for this question, right, is 265. So you would say the bearing of D from C is 265 degrees. Did you all understand that? Selma, Adika,
Yes, sir.
Ivan, you understand that?
Yeah.
Yes, sir.
Okay, great. Great. I don't want to say this name, but Liquid Diamonds. I remember that you was in one of the previous lives, but I forgot your name.
Hi,
I don't want to call you
here.
Diamond.
I just decided to use I decided to use the TikTok name, but I'm just observing because I'm not even in school. I'm just listening.
Okay, okay, well, that's fine, that's fine. Let me know if you understand what we're going on so far.
Yes.
Okay, cool.
Okay.
Cool. If all I want, take a screenshot. We're gonna move on to our second example, and I want a new volunteer. As you can see, this stuff really not that hard, and really not that hard. Give it a try. Maybe I need to pick my next victim. Who I should pick, boy? Perseus. Perseus.
Okay, sir.
Yeah, let me go Perseus. So I think I'll have a little screenshot by now. I'm gonna take it that we have this screenshot by now. Let's move on. Right. So Perseus, I'd like you to read question 2.
The bearing of a boat B from a harbor H is 250 degrees. Calculate the bearing of the harbor H from the boat B.
Wait, You see that first sentence? See this first sentence? Let me try to interpret this first. So Perseus, they're saying the bearing of our boat B from H is 250. So where should we be starting at? From Perseus, are you seeing the word from by? Yes, you would start at H because you're seeing the word from by H. So we are going to put down a point and we're going to call that point what? Tell me, Perseus, what we're going to call our point?
Not
No,
H, sir.
H. Yes, call it H. And then you're going to draw your north line. You with me so far?
Yes, sir.
And they're saying the bearing of what is from the harbor.
Repeat, sir.
They're saying the bearing of what is from the harbor.
B.
B, right? And B is a bearing of what from H? What's the bearing? What was the bearing they gave us?
150 degrees.
So Perseus, we're gonna go from the north line and we're gonna go in a clockwise or anti-clockwise direction. Clockwise or anti-clockwise?
Clockwise direction.
Right. I want you to tell me where to stop, right? Where you think is 250. Tell me, right?
Yes, sir. Somewhere there.
Huh?
Yes, sir.
So like somewhere over here.
Yes, sir.
All you agree with that? Let me know if all you agree with that. That is 250, that looking like 250. Sheena, that looking like 250.
I guess so.
Okay. I see Camila raise her hand. Camila looking like 250.
Yeah, I would say so because it passed 180, maybe a little tiny more. But one question that I wanted to ask, for exams, right, is it mandatory that we use the half circle in the geometry set to do this, or does it matter? Just
Um,
asking.
nah. Let me show you how most questions look, right? Yeah, there's really no need to dump your compass and measure no angle. You just putting it in any diagram,
Okay.
right? Yeah. Sometimes it would actually ask you to recreate a diagram. In that instance, yes, you would have to use it. But for most questions, no. Right? If you want, we could do a question where you actually have to draw it today. Fit down fit. Would you be down fit?
Sure. Yeah, no problem.
Okay, great. So Perseus, this is correct because this is 180 degrees and 250 will be a little more than 180. So great job. So Perseus, if we know that this is the bearing, right? Then what we're gonna do is we're gonna take our line and we're gonna draw it. Do you think I should move my diagram or do you think I should leave it there?
You should move your diagram, sir.
Yeah, because I don't want no space. I go run out of space, right? So I'm gonna move my diagram. So tell me, Perseus, what am I gonna call this point?
Point B.
I'm gonna call this point B, right? Is that B or E? Is that B, right? Great.
Yes, sir.
So Perseus, you understand the simple diagram we have so far.
Yes, sir.
And I'm gonna put 250 over here.
Yes, sir.
All right. And Perseus, you can read the second part of the question now. What do they want us to calculate?
Calculate the bearing of the harbor H from the boat B.
Okay, so where are we at? Where are we at? When you read that sentence, where you see the word from by?
B.
I see it by B. So we're gonna underline B. So we're gonna start by B and we're gonna draw a north line. That's the first thing we're gonna do. All right? So Perseus, if I want to figure out the bearing of H from B, I'm going to start from the north line and I'm going to go in what direction? Clockwise or anti-clockwise?
Clockwise.
So is this clockwise?
No, sir.
No, I testing all you know. I'm making sure I testing all you. Right? This is clockwise, right?
Yes, sir.
Okay. Now Perseus, let me see what you're gonna do. The two things you have to do is okay, the hints, lines, and circles. That's my two hints. So tell me, Perseus, how could I figure out for this angle? So tell me, Perseus, is there any other information we could figure out for the diagram?
I think so, sir. Yeah.
Could I figure out for this angle if I wanted?
Yes, sir.
Yeah, I could. So how would I figure out for this angle? Tell me, how would I figure out for that angle?
You have to take away the 360 from, 250 from 360.
Right. What is 360 minus 250?
110.
100. 100.
110.
110 degrees, right? So Perseus, if we know that this is 110 degrees, what would this be? So remember, the sum of angles about a line is 180. So if this is 110, what would the missing angle be?
I mean, you have to take away 110 from 180.
Yes, that's correct. 110 from 180. And what would you get?
70 degrees.
Yep, that's correct. Now, there was a more clever way to do this question. I think you all might like to see the alternative solution, but this is 100% correct. Does everybody in class understand this? I'm wondering if all you understand this. Camille, you understand this?
Yes, I do. However, does it matter if where you put the B and the H?
It does. It does. Because check this right. Check it right. Read the first part of the question.
The bearing of a boat from a harbor H is 250 degrees.
Right. So Camille, based on what's in your sentence, that's gonna tell you the starting. So I could not just put B. I had to put H over here because I started off with this information. You understand what I'm saying?
You kind of broke up a little bit. What you said?
I said the order matters. You have to look at the first sentence. So Camille, when you look at the first sentence, where are they saying from?
H.
Right. So you're gonna put
Papa
on
H.
H. You're gonna put on H. And then you go into bearing. And from point H, you're gonna drop. And it needs to touch the angle. That would tell you where B is. You understand?
Yeah.
All right. So that was one way you could do this question, but there's an alternative way you could do this question. Right. So I'm gonna call Tivon for this. Tivon, you wanna show them the electrical engineering brains? Tivon, you there?
Yeah, man.
All right. So Tivon, you wanna flex your electrical engineering knowledge? Well, mind you, this is not electrical engineering knowledge. This is like C-Sec knowledge. But Tivon, let me go through the alternative
It's
solution.
not electrical engineering knowledge.
Say that again.
This man thing I could flex in it. I don't have them kind of skills.
Only Tivon smart boy. What is saying Tivon smart? No bother with Tivon, right? Yeah. So Tivon, do you know about alternating angles? Alternating angles.
Alternate. No, that sound weird, boy. That sound like angles that'll be switching every now and again. Hold on.
It kind of sound like alternating current.
Yeah.
So let's look at an alternate, alternate solution. So let's look at an 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 altern So imagine you have two parallel lines. Imagine you have two parallel lines, and then I drew a line diagonal passing through those parallel lines. So tip one, I'm going to indicate that these two lines are parallel by drawing those arrows. So you with me so far?
Mm-hmm.
Now, what I'm saying is that the angle on the inside here,
Is the same as the angle upon the next side yeah,
yes,
like that.
that's what I'm saying. You understand?
Alternating angles. That's some weird though. Why they give it that name?
Because, okay, the angle's alternating, right? It's on the inside here and it's on the outside over here, so it's alternating.
Oh, it kind of look like a S when you draw it like that. Makes sense.
Right.
I see it, huh?
Okay. Adika, do you understand this? Alternating angles? Some of you
Yeah.
understand? Okay. I'm just gonna label it, right? This is alternating angles. Alternating angles. Now, Adika, let's just say I draw two north lines, right? I have a north line there, I have a north line over here. Tell me, Adika, are north lines parallel to each other? What do you think?
Yeah, it is.
Yeah, I would say so, right? North lines are parallel to each other. I would say that. So if it's parallel to each other, and I draw a line in the diagonal direction, so like let's just say I draw a diagonal line and it's passing through both the north lines. Do you think we could apply the alternating angles rule? Yeah or no?
Yeah, you could.
We could, right?
Yeah.
So let me show you what I mean. If I told you the angle over here is, if I said the angle over here was, what are looking like? They're looking less than 90 ends, looking like less than 90.
Yeah.
So let me just say that was 50 degrees. No, they're looking like more than 50, probably like a 70. What do you think this would be?
72.
72. I know you mean 70, yeah, but it's not like 70.
You don't say the same thing, boy. So
Like,
like you say that nobody.
yeah, right. So you understand alternating angles in the context of bearings, right?
Yeah.
Okay. Shane, are you there? Okay, and I hear
Yes,
me.
sir.
Okay, Sheena. Okay, you're here. Nice. Tell me, Sheena, and do you think you could figure out this angle here in blue? I say blue, that's
Yes, sir.
green. I promise I'm not colorblind. I promise. As you can
Yes,
see,
sir.
as you can see,
180 minus 70.
as you can see, I went on green. I went on green today. I joke,
Yes, sir.
no, I'm gone. Right? It's gonna be 110.
Yes,
And
sir.
if that is 110, what do you think this could be?
110.
Yeah, this could be 110. So alternating angles work on either side. So the angle here would be equal to the angle here, and the angle here would be equal to the angle here. Great. Do we understand that? Let me know if I understand that.
Yes, sir.
Okay. So now we could look at the alternate solution. All right. This is another way you can do the question. So Shayna, let's do the question in the alternative manner. Let me just copy and paste this diagram to save some time. All right. Right. So Shayna, and you understand the first part of the question? They said,
Here is the H, there, boy.
say that again? Or movie
I
H.
say here is the H.
Hey boy. Yeah, Shayna, in the first part of the question, you know they said they said that the bearing of B from H is 250. So we just put that back one time, right? This is 250. You understand that part, Shayna? You understand
Yes,
that
sir.
part? All right. Shayna, watch this, right? And in the question, we actually want to figure out this angle over here. That's what we want to figure out.
Yes, sir.
What is this angle over here by chance? Do tell.
180.
So if we know that this is 180, what do you think this could be?
250 minus 180.
Yes. Did anybody see that? Did anybody see that? If this whole thing is 250 and this is 180, then this small angle over here, right? That small angle would be 250 minus 180, right? And Adika, wait to tell me what that is. What's 250 minus 180?
70.
Yeah. So tell me, Adika, if we know that this is 70, what do you think this will be?
70.
Bam, bam. You see, badness, right? Yeah, that cool, Lens. That cool. That kind of cool right, when you think about it. So, which method do you think you'd use? I think most students would use this one, or like, which one you'd use? Be honest. You'd use method one or method two?
This one.
You'd use method one or method two?
Method one.
Okay. But did you see the use case of method two? Or like that kind of confusing?
Yeah.
Like that kind of confusing. It's a little
Yeah, I don't
confusing.
see it.
A little confusing.
No.
So you understand that this whole thing is 250 and this is 180. So this small piece had to be the difference.
Yeah, because it cuts on the straight line as well. So you just minus the 180 from the 250.
Exactly. I mean, that alternating angles are equal. So if this is 70, this could be 70 as well. Great. Performance, right? Right? Performance day. Big up everybody, right? Big up everybody. Right. So Camille, I think I want you to help me with question 3. So let me move on to question 3. Right? Okay. So Camille, give me a question already.
The bearing of a place X from a place Y is 265 degrees. Calculate the bearing of the place Y from the place X.
Right. So Camille, we're going to underline the first in the first sentence, where you see
What you said?
in the first sentence, where you see the word from?
A place Y.
So what is our starting point?
Y.
Why? So I'm gonna put on a point, I'm gonna call that Y. Then I'm going to draw my note line. Okay. And tell me, Camille, I'm going to start from the note line and I'm going to put on an angle of what?
360 degrees?
Mm-mm.
No,
What was-
265 degrees.
Yes. I want you to tell me where to stop, right?
Yeah.
Over here.
Yeah.
Okay, I agree. Because 265 is more than 180, yeah?
Yeah.
Yeah. All right. And I might have to make some more rooms. I'm going to right? And this point, I'm going to label this point what?
That point, the other points would be X.
Yep. And this bearing here is 265. Great. We're going to put on a note line by X as well. Because, what's the other part of the question?
Calculate the bearing of the place Y from the place X.
From where? From where?
From the place Y, from the place X, of the place Y, sorry, from the place X.
So we're seeing the word from by. In the
X.
second part. X, right? So we should be by X. So tell me, I'm going to start with multiply. And am I going to measure like this?
No.
No, that's wrong. What about this?
Yes, that's correct.
Yes, that's correct.
Clockwise.
Had to be clockwise. Yeah, yeah, clock. You gotta clock it. Right? Okay. So now we need to figure out for this. Let's use an ingenious method.
So
So-
I'll use the alternate method.
Yes, I can use that. If this is 180, right? What would this be?
Mhm. 85.
85 or
265. Take away 180.
wait, let me run back.
Well,
Let me run through. So to figure out the angle in red, it would be 265
Mhm.
minus 180.
Yeah, which will give you 85 degrees.
Yep. And for anybody that's let me explain it one more time. So guys, this angle over here will be how much degrees? Somebody tell me, how much degrees is that?
180.
That's 180. We know that. And so if the whole thing is 265 and this is 180, then the difference would have to be what? So 265 minus 180 is 85. And then Camille, what would I make this angle?
The same thing, 85.
Right, the same thing, because alternating angles are equal. Yeah. How we feeling about bearing so far, guys? Feeling good? Can we actually bear it now? The silence is
I see what you do there now, buddy.
let's try to be a little funny, you know? Let's try to be a little funny. Time to time. Right. So I see Makiba give my thumbs up. What about the rest of you guys? Adika, Camille, Darius, Ivan, Kaylee, Keshav. I don't know how to ask Keshav. I don't. Keshav, what are you doing here? Right, but it's good to have you. Perseus, Ria, look, you here. Hey, what you saying? Are you understand this so far? Were you okay with bearing so far?
Yeah, it's actually
Yes,
not
sir.
that bad.
Yeah, it's
Sir.
actually not that bad.
Sir,
Wait, Josam, yes, the answer was 85. The answer was 85. And the reason for that, Josam, is because alternating angles are equal. Watch. You have an angle here, so the angle here would be equal. I'm not sure if you're seeing that. And there was another way you could work the question out. If you know that this is 265, right? And you know that a full circle is 360, then you could have taken away 265 from 360, and I believe that would be my brain not working, 190 something, 195 or something. No, that's not like too much. 95, 5, 10, 9, 6, 10, 6. Oh yeah, that's looking like the correct answer. It'll be 95. So this will be 95, right? And then you take away 95 from 180 and you'll get 85. That's another way you could do it. That's another way you could do it. Right? So all those are alternative ways you could work the question out. Ivan, you were saying something?
sir, can you go back up to the question?
Sure.
All right. I see it now.
Josam, it wouldn't be 360 minus 85, eh? I want to just clear up some confusion for Josam. Josam, let me look at this in an alternative way because I feel like this method a bit confusing if you don't understand alternating angles. All right, so let me look at it in a simpler way, an even simpler way. Right? So Guys, TikTok pull up a capture. They think guys are robots. That's crazy. Hey boy, I had to do a puzzle, boy. Seriously, TikTok? Bro. All right. Let me just re-explain this quickly, right? So Joshua, another way to handle this question, right? We know that this is 265. This would be 360, so we can figure out the missing angle over here, right? If we were to do that, you'll get that this is 95 degrees. You'll get that is 95 degrees. And so the next step would be to take away 95 from 180 to figure out this angle over here. So that'll be 180 minus 95, and you should get 85 degrees. Right? And that's that. It's another way you could look at it. Right. Ivan, you want to do a question with me?
I guess.
Ivan, you can't stay hidden for too long. You had to give it a try. Yeah, you know, what doesn't kill you does make you stronger. Right? And it, guys, just some inspirational advice. You will get nowhere in life if you stay in a comfort zone. Only thing I know nervous to just do a random TikTok live and thing. Like, trust me, guys, I cannot nervous. But you know, we're winging it. Yeah. So, Ivan, pass aside the
Yes, sir, yes.
just like pass aside all the fear and the doubt and just go into it with an open mind and try it. It really not that hard. I promise.
All
So, Ivan, give the question a read.
The bearing of an airport A from a plane P is 310. State
All
the
right.
bearing of the
Wait,
plane P
wait,
from the
Ivan.
airport.
Let me take it one step at a time. So let me just look back at the first sentence. Where do you
Okay.
where do you think the starting point is from that information? Where do you think we're starting at?
So P.
We're starting at P, right? Because they said from a plane P.
From P.
Great.
Right.
So I'm gonna put on a point here and I'm gonna call it P. Then I'm going to put on a north line. I'm gonna put on a north line here. All right, I put on a north line. You with me so far?
Right.
And we're gonna do a bearing now. And the size of the bearing is gonna be how much degrees? What's the size of the bearing?
So 310.
310 degrees, right?
Right.
Now, are we going to measure the angle like this? Is that clockwise?
So nah.
Nah, trying to tie up the ends. Right, that's not correct. What about like it? What about like that?
Yeah.
All right. I want you to tell me where to stop. Tell me where you think 360 would, 310 would be. Where do you think 310 would be? Tell me when to stop, right?
Stop.
All right, I will stop over there. All right. So like right here, right?
Yeah.
Okay. Say no more. Take it with it. Right? Then the next thing we're going to do is we're going to draw a line from the point and make sure it lines up with the arrow, right? The arrowhead of the angle. And what are we going to call this point, Ivan?
So A.
We're going to call that A. And Ivan, what we should probably put by A one time. Let me not stick. What should we put by A one time? What line? We should put a line by A.
So
What do we call this? Call that
not.
north line. Right? So we're gonna put on a note line one time. We don't play. We gotta put on a note line.
One more. Oh, all right.
Right? Nice. Now, Ivan, let's read the second part of the sentence. The question. So they're saying,
Right. State the bearing of the plane P from the airport A.
all right. So, Ivan, we know that this is 310 degrees here. And according to the question, they want us to figure out the bearing of P from E. So where are we at? According to the second part of the question, where should we be pointing at?
So A.
We at A right now, and we want to go to P, right? So am I going to measure? Am I going to measure my bearing like that?
Nah.
Nah, don't do that. I have to measure my bearing in this direction, yeah?
Right, right.
Nice. So tell me, how do you want to go about this question? There are two ways you could do the question. How do you want to go about the question?
So you're going to take away 180 from 310?
Okay, sure, we could do that. And would we be fining for this angle?
Yes, I think so.
Yes. Yes. So, Ivan, do you understand that this is 180 degrees
Yes, yes, yes.
and this whole thing is 310?
Yes, sir.
Nice. So if I want to figure out for this angle here, it would be like what you said, it'd be 310 minus 180, yeah?
Yeah.
What would that be? It's Yvonne. You see my girlfriend on TikTok live on trolling. You see she trolling.
So hold on.
I see now.
Yeah. Check she. Sir, I don't want to go about nothing. I want to sleep. And for some reason I awake. Oh yeah, that's my girlfriend. I
So
see the,
130.
yeah. Yeah, Ivan.
So 130.
130, right? So tell me, Ivan, if that's
Yeah.
130, what do you think this would be?
So
Remind me, Ivan, watch. Check
now you
this
say
out.
130.
So if this is 130, then this would also be 130.
Yeah.
That's what I was saying,
Right, right.
right? So this is so this answer here is 130 degrees. Right? Are you understand that? Tell me if you
Yeah.
understand that. How about the rest of you guys? I don't like the silence. The silences make me go crazy. Are you understanding this?
Yes, sir. Normal.
Somebody said Suski. At that point, Bessie just called me Saski. Right? Somebody said Suski. All right. So at this point in time, we have a very good grasp on bearings. The next part of this is understanding where to throw in trigs into this. So you need to understand the sine rule, the cosine rule, and really, but you need to know Pythagoras theorem and trig ratios. When you're doing a bearings question, it's usually sine and cosine rule. So we're gonna move on to that just now, right? But Camille, I didn't forget you. You said you wanted to do some questions where you actually measure it with the protractor. Yeah,
Yes, sir.
guys. For some reason, I know as a math teacher, right? I should know what's the name of this, right? I just always mix up the name of this because it does look like a compass, eh? It's actually a protractor. That's my one beef. They should have called this a compass, right? So, Camille, I want you to pick a question, 1 to 4, and we're gonna actually do the thing, actual drawing, on the board. Pick one, 1, 2, 3, or 4.
We can start with the last one.
Last one, sure, not a problem. Right? So, drawing bearings with an actual. Alright, give me a second. I'm just gonna swap out my Apple Pencil tip. This one cannot be enough. Okay. Right. Yeah. Let me get back into it. So question 4. So according to the first part of the question, we know that we started from P, right? So I'm gonna put on a point P, right? And Camille, we're gonna draw a note line.
Mute them mic as well.
Yeah. Camille, I believe it's your mic that's having the pickup while here in the south. If you're not talking, mute your mic. Yeah. All right. So let me see if I can find my protractor. It's supposed to be here somewhere. Somewhere. Here it is. My digital protractor. Great. All right. So Camille, do you understand that we already know that this is already 180? And we know that? Camille, let me know if you understand.
Yeah, you're hearing my better now?
Yes.
Okay.
Great. So Camille, we already know that this is 180. And the total bearing is 310. So what would be the missing portion?
50. 360 take away 310. Oh no, sorry. 130. Sorry, my bad.
Maybe 130, right? Now we're doing this because the protractor, it only goes from where? 0 to 180, right?
Mm-hmm.
Right. So I'm gonna take this thing, gonna line it up with the north line, and we're gonna measure how much degrees.
Right.
So we already have 180 in the bag. How much degrees we have to go again to make 310?
130 degrees.
Right. So 0, 10, 20, 30, 40, 50, 60. All right. 130 would be here. Let me know if you understand how I do that.
Yeah.
So that is shell bearing. And all together, it would be 310. So how you find that was?
Easy. Easy, that means squeezing.
I tell you, now, most things in maths actually not that deep. It's not that deep, bro. A lot of things in maths, not that hard. All right. So just to label this a bit better, we know that this is 180 degrees, right? And this will be the 130 we measure with the protractor. Right. So Camille, we know that this is what point? What is this point? Camille, what's this point here, right?
Yeah.
I'm gonna put on one outline. And according to the questions, we need to answer this angle.
Yeah.
All right, so I'm gonna take my protractor. I want you to measure that. How much degrees does that look like?
130.
130, right? And if anybody is confused, watch, this is 0. So count with me. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. Right. People in the TikTok, will you understand that? Let me know if you understand how I measure the angle. And people that in the Zoom meeting, did you all understand how I measure the angle? Let me know. Adika, you there? Sheena, Perseus. I understand how I measure the angle.
Yeah.
Okay. Right. So Camille, you feeling comfortable with this now?
Yes, sir.
Right. Just for safety, would you like to do another one?
Yeah.
Okay, pick one. 1, 2, 3, or 4.
Two.
Well, 2, 4. So 1, 2, or 3. Pick one.
Two, sir.
2. All right. So we already know how this is going, right? Where we starting from? What's our starting point?
H.
H. I'm gonna put on H, right? Somewhere. So I put on H over there. What's my next step? Ryan McCamille, what's my next step? What line do I need to draw?
The north line.
To draw the north line,
The
right?
straight line. The straight line, north line.
Right. And this bearing was 250. We already have 180 degrees in the bag. It's 180. So how much do we need to go again to make 250?
70 degrees.
Yep.
250 minus 180 is 70 degrees.
Right. So we're gonna take our protractor, line it up here, and we're going to measure 70 degrees. So 1 second. Good notes bugging, man. I don't like good notes. Like good notes is real bugging these days. Like real bugs. Okay, that will work, right? So Camille, tell me when to stop.
Yeah.
All right. So this angle here is 70, yeah? Some of you understand that.
Yes, it is. Yeah.
And the full angle would be 250 as
It's
a result.
250.
Nice. What are we going to call the other point?
B.
Going to call the other point B. Great. What I need to put on by B?
The north line or straight line.
Yes, put on the north line. Somebody should make a super song about that. Like a carnival song. Need to put on the north line.
Say you make it up.
I feel so. It have potential there. It have potential there. Need to put on the north line. I feel so. I can get any lyrics already. I get any lyrics. I'm gonna make a song. Right? Forget Marshall Montana was Reggie Warwicker. Actually, I doubt I could beat Marshall Montana, but it will be the first for Matsuka. Anyway, let me continue. So, Camille, in this question, we want to figure out this angle length.
Yeah.
Right. So I'm gonna take my protractor, line it up with the north line. How much are you looking like? How much degrees?
So by the way, we clip that.
Yeah, clip that, and add beats over it. Make it a whole song. Yeah. Camille, how much degrees is that?
17.
Right. And if anybody confused, we add 0 degrees by the north line. And if you keep counting, what 0, 10, 20, 30, 40, 50, 60, 70, bam. 70 degrees. So, Camille, you have any confusion with the concept of bearings?
No. I just need to remember where to place the protractor on the line.
All
like
right.
the direction in which to have it placed, now, if you understand what I'm trying to say.
Yes.
But so far, so good.
All right. I want to figure out some way to clear that doubt before we move on. A lot of students has had a doubt. They doesn't really know where to put the protractor. So, like I said, let me address that, right? Yes, this is the same thing as geography. Maths is guys, maths is the foundation for most things in life and most subjects. So yeah, they use this in geography. It's the exact same thing they use in geography. Right? Right. So Camille, let's try to understand the placement of the protractor. If I put the protractor over there, does that make sense? Does that make sense? Put the protractor over there.
I would say yeah, because I've seen the zero.
Right. But look at where you would be measuring. You'd be measuring things from here to here. Are you seeing anything that's on this side? Are you seeing anything
What
on
do you
this
mean?
side? Let me give you an example, right? If you put your protractor over here, what are you measuring?
Nothing.
You're measuring something. You're measuring the angle of the note line. What's the angle of the note line?
180 degrees.
But do we need to find that?
No.
Well, we know that already,
It's a
yes?
tiny message.
Yeah. So does it make sense to put this over there?
No.
No. What if I were to rotate it?
Yeah.
Does it look like it makes sense then?
Yes, it does.
Because we're starting from 0 here. And remember, we measure the angle in our what direction?
Clockwise?
Right, watch, clockwise. So I hope you're clear with that. Yeah. If you want to measure an angle over here, your protractor should be like this. If you want to measure an angle, okay, come here. Let me just say you wanted to measure 180 over here, right? Would you put your protractor like this? Or would you put your protractor like that? One or two?
I'll put it like one.
I'll put it like one as well. Yeah, watch. You understand?
Yeah.
And if I wanted to measure an angle on this side, I would rotate my protractor like this. Right? And let me show you something to me. You see this north line over here? Well, this would really be the south line, right? This is south. But anyways, come here, you see I have a line here, right?
Yeah.
This will be 0. And so you see, it would be 70, right? It would measure 70, correct?
Yeah.
Great. Now, you could also measure this angle. Camille, give it a shot. See if you can figure out what this angle is by reading the toe of the protractor.
What I would have done is put the protractor on the red line.
Nah, you don't have to do that.
Or
You can
just
see.
count it.
All right, so Camille, watch this, right? You see how the protractor is lined up on this line?
Mm-hmm.
Okay. So there's 0 to 180 here. And there's also 0 to 180 here. See now?
Yeah.
Okay. So if we start in from here and we want to measure this angle, let's see how that would go. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 100 and what?
10?
Yes. Understand?
Yeah.
So you didn't have to move your protractor at all. Didn't have to move. Right. So I hope you understand that. All right.
I think working out the sum will be my safest bet, and if I have to like draw it, yeah, we use that accordingly.
Hey, what my advice is, do whatever makes sense.
Yeah.
It's only like stupid advice. But like what?
No, it makes sense, no.
You're saying that I was gonna line up your protractor with the red line like this? Okay, you know that could work. That could work. But let me show you. We will be actually watch. Yeah, that would work. That would work. That's correct as well. So if you did that, it would be correct as well. Yeah. Yes, you see what I mean? Watch. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Some of you understand that as well.
Okay.
Yeah. Feeling okay with your protractor now?
Yeah.
Okay. Anybody in the Zoom or anybody in the TikTok live have anything or they want me to explain before we go forward? Darius, I know you said you had real problems with bearings. Have anything you want me to re-explain?
No, so far we chilling.
All right, we're chilling. Great. So quick recap before we move on. Very quick recap. Darius, when you see the word from in bearings, what does that tell you?
That's your starting point.
Right, from, that is your starting point. What should you put by each point? What should you put by each point?
Your note line.
Right.
And always move in a clockwise direction.
Right. Put the note line by all points. Right. Right. Always measure angles. Always measure your angles in a clockwise direction, starting from the where? Starting from the what?
Starting from the note line.
Yes, you always start from your note line. Always measure your angles in a clockwise direction, starting from the note line until it touches the line connecting the 2 points.
So,
Yeah, Ivan?
after class, give me some more, like, couple questions.
Okay, no problem. I think I want to have a live stream tomorrow. I'm doing this like leading up to Christmas.
More.
So I have some other number, but I don't have some other numbers. So the people who numbers I have, I can send all their homework. Yeah. All right.
So tomorrow gonna be the same topic or a different topic?
We're not gonna finish bearings, I can tell you that, right? Because we still have sine rule, cosine rule to learn, and then do like CSEC questions. Yeah.
Okay, sir.
Right? So when you see where from, that's your starting point. You're gonna put the note line by all the points. You're gonna measure your angle in a clockwise direction. You're gonna start, so starting from the note line, you're gonna draw your angle until it touches the line connecting the 2 points. Always remember, sum of angles for a circle is 360, and for a line is 180. Also remember alternating angles. These are the things you need to remember when dealing with bearings, right? So, Kelly, are you still there? I wonder if you're still here.
Yes, sir, I'm still here.
I'm surprised.
I think I have to leave just now by like 9.
Okay. Right? Because I know, guys, If you ask, I like maths. Actually, I was gonna say is Christmas holidays. What are you doing on a live doing maths? Right? But then I was gonna say I myself wouldn't do that, but literally doing it. So that would be like contradicting myself. But yeah, I'm surprised all they here. All they have all like Christmas vacation. I guess all they locked in, that's good. Right? So Kelly, we understand the basics of bearings. Would you like to see it in our past paper question now?
Sure.
Let me look at our past paper question, shall we? All right. So this is from June 2017. We're not going to, guys, we're not going to do part 3 and part 4 yet because those are advanced questions and you need to know the sine rule and the cosine rule to do it. But those that stay to the end, we will cover the sine rule and the cosine rule. So by the end of today, you should be able to handle a CSEC question, right? But up to this point, I'm only gonna ask you to answer part 2, right? So Kaylee, read the question for me.
Okay. A ship leaves port A and sails 52 km on a bearing of 44 degrees to port B. The ship then changes course to sail to port C, 72 km away on a bearing of 105 degrees.
Right? On the diagram below, yeah.
On the diagram below, not drawn to scale, label the known distance traveled and the known angles.
Right. So let me understand what the first sentence saying, right? That's the first thing we should be interested in. So where does the ship leave from?
It leaves from port A.
So do you think that's the starting point?
Well, yeah, that's where it's leaving from.
Exactly right. So we're gonna start off at E, right? So according to the first part, we're gonna start off at E. So you're starting off at E, starting position. Great. And what does it do next? Tell me, what does it do next?
It sails 52 kilometers on a bearing of 44 degrees to port B.
Right. So what do you think the distance between A and B is? Based on that information, what do you think the distance between A and B is?
Will it be the total amount of degrees? But
Wait,
I'll
you're overthinking this. Okay, when I say the distance, what unit are you thinking of? Like, what do we measure distance in? Distance.
kilometers.
Right. Let me read back that question one more time. So the ship, I'm gonna pretend there's a ship here, right? Wait, let me actually draw a ship. I'm gonna draw the Titanic over here. And they're gonna have an iceberg over here. They're gonna have a big iceberg over here, right? This is Titanic 2.2, the never seen version. Are you lucky to be seeing this, right? It'll be funny if I call this the Fata Rosak. And this was Trinidad. But this is the Titanic. Right. Yeah. So Kaylee, the Titanic starting off at A, right? What are you doing next?
It's traveling 52 kilometers on a bearing to B.
Right, so what was the distance to travel from A to B?
Oh, 52 kilometers.
Yes, man. Yes. I tell you, see, a lot of things in maths very easy. It's 52 kilometers here. Right. Oh yeah. And when the Titanic reach over here, it break, it sink down. So cue the sad music. Right. Okay. And where do you think I should put the bearing? You think I should put the bearing by A, by B? Where do you think I should put the bearing?
By B?
No. Where did you start from?
Oh, A.
A. And how did you go from A to B?
By sailing
Right? On a bearing or what?
44 degrees.
Right. So to go from A to B, you had to take a bearing of 44 degrees. So this is the answer to the first part, 44 degrees. Let me explain that one more time, right? So Kaylee, do you understand you're starting off at A and then going to B?
Yes, I understand that much.
So wherever you're starting from, the bearing is always going to be from the north line to the line that connects the starting point and the ending point. So Kaylee, let me show you something, right? Imagine, check this, right? It will make so much sense. So much sense, I tell you. Watch this. I want you to think of that 44 degrees as really a direction, right? Watch this. So Kaylee, if I check this, right? I'm gonna sail the Titanic in a bearing of 44 degrees. Watch, we're gonna, and I want you to tell me where I end up. Watch. Where did I end up?
You end up by port B,
Exactly. So what bearing did I take to reach there?
44 degrees.
Yes. All right. So this is what sailors actually use. Right. So as you can see, if we keep on our bearing of 44, we'll travel on the line AB and eventually we'll reach B. That's how it does work. So that's the first piece of information we put down. Guys, would you all have figured out that part of the diagram? Darius, yeah or no? Did I figure out that part of the
Yes,
diagram?
sir, that part. Yeah.
All right. Let's move on to the other sentence, right? So Kaylee, read the other sentence.
The ship then changes course to sail to port C 72 km away on a bearing of 105 degrees.
Right. So let me just, I tell you, this is a special version of the Titanic. You know, this is like a big plot twist. Apparently, the Titanic survived. Wow. Who would have seen that coming, right? I would not see that coming. All right. And so Kaylee, the Titanic reached B, and from B, where is it gonna go next?
To port C,
Yes. What's the distance between B and C? What do you think?
72 kilometers.
72 kilometers, yes. And according to the question, where do you think I'm going to put the bearing of 105? Do you think I'm going to put it by B or by C?
By B.
Yes, because the sailor would have to use that bearing to go from B to C. Understand?
Mhm.
And if you look at it, and it's looking a little more than 90, so like 105.
Yeah, it is.
Yeah, all these things is hints, right? So I'm going to put on 105 over here, 105 degrees. Camille, do you understand everything so far?
Yes, sir.
Okay. Perseus, Sheena, Ivan,
Yes, sir.
do you all
Yes, sir.
understand what's going on?
Yes.
Okay. Darius, you sure you understand?
Yes, sir.
Okay, I see somebody on TikTok said they don't understand. Okay, which part I lose you at? Come on, which part I lose you at? Guys, it's really be weird to call out people TikTok name, man. Like who's pretty face and what confused you? Until you know that meme with like when you have to give somebody an email, or you know what I'm talking about? That meme?
Yes.
Yeah, and it's like your email has some like weird name, and you have to give somebody that, and it's like a professional thing. All right. So who's like, I crack up too much, you know. But the person that was confused, let's just run through the question one more time. So they said a ship leaved port A. So if this is A, this is where we are starting from. We're starting from A, and then we're sailing 52 kilometers on a bearing of 44 to B. So we know we went from A to B, and that was 52 kilometers, right? That was 52 kilometers. Now, the bearing we used to travel to B was 44. So that would be the bearing you took from the starting point. Again, let me show you something, right? To the person name that I don't know. I just know who's it's interesting. All right. So the person on the TikTok that's confused, right? Look at this. I want you to look at this carefully. And you go understand bearings from this. So apparently, the bearing that we are taking to go from A to B is 44. So watch this, right? Check this out. Let's just say we had the Titanic over here, and we're starting from A, and we keep traveling in this direction, so 44 degrees. If I keep traveling in 44, I end up at where? Where do I end up at? If I keep at a bearing of 44, where do I end up at? To the person that was confused on TikTok, where do we end up at? Wait, give me a second, guys. Yeah, to the person that was confused, where do we end up at? Who's gonna call the person who's? Right, I'm not hearing from them on the TikTok, but eventually we end up at B. So your question was 105 degrees. I thought you were starting at C, not B. Okay, so again, for the person that's confused, we started off at A and eventually we reached B, right? And in the question, they said the ship then changes course to sail to port C. So do you understand that right now we are at B and we want to go to C from here? Let me know if you understand that. So we at B and the next thing we want to do is want to go to C. Let me know if you understand that. So the person on the TikTok that's confused. So we went from A to B, and from B, we're going to go to C now. Now, obviously, if you want to go from B to C, you'll have to take a different bearing. Now, remember, bearings start from the starting point, right? So, to the person on the TikTok, if you're now at B, then you're going from B to C, from B to C. So you'll have to take a new bearing. And the new bearing they gave us was 105 degrees. So the bearing is always from the north line and from the starting point. So you're starting at B and you want to go to C. And let me just do something that will clear up any confusion, hopefully. I'm going to erase my Titanic for a bit. Let me just get a better version. All right. Any of you ever watched Titanic or like a little young to know about Titanic? All you know about it? All you know about that? People on the Zoom here.
Yes.
Think so?
Right. Right. So watch this, guys. I'm going to draw a bearing of 105. You're going to see something very cool. So the captain is in the boat and they are taking a bearing of 105. So if I stay on course, on that bearing, look at where I end up at. So I'm staying on the bearing of 105 degrees. Bam. Guys, where do we end up at? Where do we end up at? Tell me, guys.
Let's see.
Yeah, we end up at C, right? So who's Pretty Face? Again, I think you should tell me your name. I don't want to keep calling you by that name. I'll crack up, right? So, do you understand why we're putting the 105 over here? You always put the bearing at from where you're starting from. So we started at B and we went to C. So we place the bearing from the starting point B. That's what we do. Okay, great, Nicolette. Nice. Nice. Okay. Camille, you ever thought about bearings like this? Tell me, Camille,
What you said, sir?
you ever thought about bearings like this? Watch. I'll do it back one more time. So Camille, and you see that this is 105 degrees over here? There's this angle here, and this is 105.
Yeah.
Watch this, right? If the captain in the boat stays on that bearing, look at what's gonna happen. You see that, right? Where do they end up eventually?
I see.
Yeah, see. So that's how bearings is work. If you have a bearing, it keeps you in line to where you want to go. Right? So this is a practical demonstration. Right.
Okay.
Great. Wait, give me a second, guys. One momento. I'm gonna do something hilarious. Give me a second. Lights on it. All right. Right. Yeah. Yeah. So this was the Titanic, guys. All right. Okay. So will you understand how to answer the first question? Just like that, you would have gotten 2 marks. Let me know if you understand that. Darius, do you understand that? Like actually understand that?
Yes, sir. Everything so far is very clear.
Okay, good. So Darius, let's answer part 2 now. Can you read part 2 for me?
Determine the measure of A, B, C.
All right, A, B, C. Now, this is something else that confuses so much students. It's not even funny. So when you see something like ABC, don't go and write D, E, F, G, right? If you see something like ABC, they don't mean to finish the alphabet, right, guys? They don't want you to finish the alphabet. Darius, will you be finishing the alphabet if you see ABC?
No, sir.
Yeah, sure.
Yes, sir.
Okay, Kelly, will you be finishing the alphabet if you see ABC?
No?
Okay,
That
good.
sound like something you go do.
What that sound like?
That sound like something I go do.
Yes, that is something you would do. That is something. By the way, Tavon, watch. Anywho, so when you see something like ABC, they are referring to the angle in the middle. So if you see this, they are referring to angle B. Angle B. All right, guys? Angle B. So let's try to understand what I mean by that. So Darius, ABC. So ABC. Darius, where you see the angle forming?
In the middle.
Over here, right?
Yes, sir.
Great. So that's what they want us to find. Can everybody see that? When you see something like ABC, they are referring to the angle in the middle. In the middle. I remember this one song, splitting the. Anyway,
All right.
I'm gonna go so far.
Now the platform for that.
Remind me of our song.
Now
It remind me of our song, right? It remind me of our song. Anyways. So anytime you see this 3-letter notation, the angle in the letter in the middle is the angle they're talking about. So Kelly, if you see ABC, right? ABC, they're talking about the angle in the middle. All right? ABC, angle B. Do you understand that?
Yes, sir.
I call Kelly. Wait, I see that my internet connection is unstable. Are you hearing me well? Let me know if I hear
I
Yes,
me.
sir.
didn't hear
And
what you
normal
said,
now.
my had stick.
All right, so Kelly, I was asking you, do you understand the 3-letter angle notation?
Yes, sir.
All right, yeah, sure. So like, if you see ABC, you understand that they're talking about angle B, right?
Yeah. Yeah.
Okay, so, and if you don't understand that, watch this. ABC. Where does the angle look like it is? And the angle is formed
Could you
between,
repeat?
if I were to draw ABC, where does the angle look like it is? So an angle is formed between two lines. So Kaylee, what two lines are you seeing here? Yeah, now but we'll watch it again, right? A to B and then B to C. So check it out, right? A to B is AB and B to C, that's BC. Two lines. See any two lines? Watch. One line here and one line here. See that?
Yes, sir.
And an angle is formed in between two lines. So the angle would be here. That's it. So that's angle B. Talking about angle B. Let me know if you understand that.
Yes, I understand now.
All right. I see Shireen on TikTok mashing it up, man. Yes. Get them heat, Shireen. That's correct. That's correct. Nice. So let me just put in the angle they want us to find for. They want us to find for this angle over here. I'm going to call this angle B. Right. So Darius, you're going to help me with this question, right? Okay. So Darius.
Yes, sir.
What is this? In red. What's
Angles at that point?
angles at that point add up to?
360 degrees.
Okay. So if I knew what this angle was, would I be able to figure out for angle B?
Yes, sir.
Okay. We know that this is 44. Is it possible for me to figure out for this angle?
Yes, sir.
Yes, it is. It is possible. So we need to figure out for this angle over here. Tell me, how would I figure out for this angle over here?
So basically, that's a straight line.
Yeah.
So it would add up to 180 degrees. To find the angle you're looking for, you minus 180 degrees from the 44.
Wait, I think you mean to say we minus 44 from 180.
Well, yeah, 44 from 180.
Right? So what's 180 minus 44 degrees? 136.
136.
All right. And if I know this is 136 and I know this is 105, could I figure out this angle here?
Yes, sir.
I can. How am I going to figure out the angle B? How am I going to figure out that?
By adding 136 and 105 and minusing it from 360 degrees.
Yes. So I'll say 360 minus 136 plus 105. 136 plus 105, that's 241, 241 from 360. That is
119.
190. So my answer is equal to 119 degrees. So Darius, you could imagine just like that, you get 4 marks.
Yes, sir.
Yeah, you just like that, you get 4 marks. So that was an easy 4 marks, so if you ask me, because we just had to label the diagram. We just had to label the diagram, and then we just had to figure out ABC. I think that 4 marks very attainable. The hard questions are part 3 and part 4. Right? I see somebody asked me, why did I say 360 minus 136 plus 105? Wait, no. Can you explain why you did 180 minus 44? Okay. So anytime you have angles on a straight line, they add up to 180. So I'm just going to call it Isabella. So Isabella, anytime you have a situation like this, the sum of angles about a line is 180. So if this is 44, then whatever this angle is here, when I add it to 44, I'm supposed to get back 180. So in other words, 44 plus this angle supposed to be 180. So if I want to figure out the missing angle, I would take it away from 180 and I get 136. So Isabella, do you understand that if you add 136 and 44, you get back 180? Tell me if you understand that, Isabella. Isabella, let me know if you understand that. So I'll say it one more time. The angles about a line add up to 180. So if this is 44, this has to be 136 to give you back 180. Right? So Isabella, let me ask you a question, right? If we know this is 105, you think you could figure out this angle here? If this is 105, see if you could figure out this one. That's my challenge for you, Isabella. If I know this is 105, what should this be? So we know it's supposed to add up to 180. So see if you can figure it out. I know you can do it. Yes, 180 minus 105, which would be 75 degrees, because they have to add up to 180. Great. So people on the Zoom, do you all think you could easily get those 4 marks? Let me know. Let me know, guys. Yeah or no? Have anything only want to re-explain? I don't mind re-explaining. That's fine. Sanjay. Sanjay, are you here? Sanjay, feel free to unmute. I don't bite, I promise. My teeth big, but I don't bite.
Oh, yes, sir.
Okay, good. Right, so Sanjay, you was asking me when to use your protractor.
Yes, sir.
You would use your protractor when they tell you, okay, do the actual diagram. So you see how in this diagram it says not drawn to scale?
Yes, sir.
They don't expect you to put on your protractor and actually, do all of that, right? But if you see a blank, okay, if it was completely blank over here and they said draw the diagram, then I would recommend you to use your protractor. But you see how they give you a diagram and it said not drawn to scale, you know how to use your protractor. It's just a sketch. Yeah. Sanjay, we would do some
So,
questions.
sir,
Ivan, you were saying something?
so yeah, the final answer is what?
Wait, so Nicolette, yes, once it's on a straight line, they have to add up to 180 degrees. So again, check this out, right? This is 44, this is 136. How to add up to 180? Watch it again. There's 105, and this has to be 75. Have to add up to 180, Nicolette. Have to. If it's not adding up to 180, something wrong. Right? Something wrong. Right. So Sanjay, if I find
a little bend some way.
say that again.
I say if this one of them ain't add up to 180, the line have a little bend some way.
Yeah, something wrong there. Something wrong. Right. So Sanjay, most questions, you actually have to, you know how to use your protractor, right? Where you will have to use your protractor is like I think question 2, where you have to actually do a geometric construction. But under this topic, I really, really doubt you'll have to use your protractor. Most questions, you don't use your protractor. All right?
Sir,
Yeah. So I'm going to move on now. Let's look at the
sir,
next question. Yeah, Ivan?
sir, angle B is 114.
Angle B is, wait, I don't know how I get 119 over here. Bro, what? 136. No, it's will be 119. Yeah, just check that for me. Actually,
Oh,
I have a Casio right here. I have a Casio with my right here. All right, so 360 minus 136 plus 105. Yeah, 119. So the final answer for angle B is 119. I don't know where I get 114 from. My bad. Right?
oh.
Yeah. Let me know if you guys understand that. Everybody okay? People on the Zoom, I don't like the quietness. Somebody say something. Somebody say something.
Yes, sir. We understand.
Yes, sir.
Thank you, Sheena, for not leaving us stranded, right? Thank you, Sheena. Thank you for not for telling me I can't fit on the door, you know?
Yes.
The last scene in this, dog, it had enough space for Jack Boy. Boy, Rose didn't love him enough. Do get somebody like Rose, eh? They have enough space on that door. Right? Let's do our next question, right? Let's do our next question. So, Shina, let's handle January 2017. Give it a read for me. Look at that ship. What is it? What is this with them on ships? But yeah. Read January 2017 for me, Shina.
A ship travels from okay.
Akron.
A ship travels from Akron on a bearing of 30 degrees to Belleville, 90 kilometers away. It then travels to Compton, which is 310 kilometers due east of Aiken, as shown in the diagram below.
All right.
Indicates on the diagram the bearing 30 degrees and the distance is 90 kilometers and 310 kilometers.
All right, so Shina, let me show them. Let me show them. This is gonna be easy marks, right, Shina? So, Shina, let's interpret the first sentence. So, Shina, in the first sentence, where are we starting from?
Aiken, so A.
We're starting from A, and we're going where?
B.
B. So, should I put my bearing by A or B?
A.
You said by B?
A.
A, yes, A. The bearing is always by the starting point. Always by the starting point. Right? Alyssa, I see Alyssa join. I wonder if you have anybody else I know here, boy. Nah, right? So yeah, Shina, we always start from the starting point. So the starting point A, right? So I'm gonna put 30 degrees here. And Shina, do you understand? Wait, let me just get this. Give me a second. Copy this. Nice. Shina, check this out, right? Check this out. Could I remove the background in this thing? Okay, I don't think so. Wait, give me a second. Right. So, Shina, check how cool maths is. Maths is very cool. Check this out. So, Shina, and you understand that what I just now draw was 30 degrees? You see that, right? That's 30 degrees. You can see that.
Yes, sir.
Okay. Let me just say we start off from A with a bearing at 30. If we keep on that bearing, where are we going to end up at?
B.
Yes, very cool, right? Very cool. Very cool.
Yes.
Okay, and what is the distance from A to B? What do you think? A to B.
90 kilometers.
Right, 90 kilometers. Right? And okay, let's dissect the next sentence. Read the next sentence for me.
It then travels to C, which is 310 kilometers due east of B, as shown in the diagram below.
Right. So when we reach B, we ended up traveling to where?
C.
Right. What's the distance from B to C according to the question?
310 kilometers.
Yeah, that's an easy 2 marks, eh? Easy 2 marks. They're not even trying at this point. That's real easy. Right? The next questions you'll have to know sine and cosine. Let's do one more question, and then we'll look at sine and cosine rule. Right? Things might get a little bit complicated there. I got a little complicated. I just knocked on my phone. Sorry to the people on the live. All right. So, what's the call on this boy? Sanjay, there?
Yes, sir.
All right, Sanjay, I'll wait to get the question. I'll read it. Get the question I read.
The diagram below, not drawn to scale, shows the relative positions of three fishing boats, K, L, and M. L is on a bearing of 40 degrees from K and M due south of L. LM equal 120 kilometers and KL equal 80 kilometers.
All right. So Sanjay, according to this sentence over here, right? It's saying L is on a bearing of 40 degrees from where? From where?
From K,
From K, right?
yes, sir.
So where do you think I should put a point at? Where do you think I'm starting from? According to that, where are we starting from?
From K,
Exactly. I'm starting from K. And
you
what?
starting at K.
And the bearing will be what? What's the bearing?
40 degrees.
Right, because it said to go from L. If you're at K and you want to go to L, you have to take a bearing of 40, right? So this will be 40 degrees over here. You understand this?
Yes, sir.
All right. So on the diagram, show the bearing of 40 degrees. Great. Now they want us to calculate the measure of angle KLM. Okay, sure, no problem, KLM. So Sanjay, if you see this three-letter notation, it tells you that the angle is in the middle. So we actually want to find angle what here? Angle K, angle L, angle M. What do you think?
Angle L.
Angle L, right? And if you're looking hard to understand, check this out. KLM. Where does it look like the angle is at?
Does it look like it at L?
And you can see that, yeah, it's looking like it's at L, right? Because it is at L. So this is what we want to figure out. So we want to figure out. Now this is so easy, yeah? It's so easy, right? But Sanjay, at L, let's draw a north line, right? Let me draw a north line, right? And I want to cement something here. So Sanjay, read this for me. Read that for me.
M is due south of L.
Right. It's due south of L. Let's try to understand what's going on there. So Sanjay, and this will be a north line, and that will be a north line.
Yes, sir.
What would this be? What would this be? Tell me.
South.
South. And didn't they say that M is due south of L? And you can see that, and you can literally see it. M is due south of L.
Yes, sir.
Okay. So if that's the case, it means that this line and this line are parallel to each other. So what do you see it's forming, Sanjay? What is it forming?
Would you have to use alternate angles like a Z?
Yes. Once you have two parallel lines, right? And you have a line passing through the parallel lines, the angle on the inside is equal to the angle on the outside, and vice versa, right? So this is 40, this will be 40 as well. But there was another way to calculate it, right? Well, let me know if you understand that. You understand that?
Yes, sir, I understand that.
Okay. The other way to do it would have been to do it like this. So if we know this is 40, right? We know that it's 40, then what would this have to be then?
That would be 140.
That would have to be 140. And if we're dealing with a straight line here, tell me, what would this have to be?
180 degrees.
No, that would have to be 180 minus 140. I'm gonna run that back one more time. So you understand that this would have be 140, yeah? That'll be
Yes, sir.
140. And if this is a straight line, and we know that this is 140, how would I figure out what this missing angle?
180 subtract 140. Sorry, I thought he was asking for like the whole angle.
Okay, I understand. But that's the other way you can calculate it. But I think everybody could see that it's alternating angles. So just like that, you'd have gotten 2 marks. Okay, great. Right, so for this question, alternating angles. Would you all be interested in getting the notes after class, after the session? Let me know.
Yes, sir.
Yes, sir.
Okay, no problem. If you do have my number and you want my number for me to send you the notes, I'm just send my number in the chat. 784 2630. All right. So I think we do enough diagrams. I think everybody here have some better understanding of bearings. Darius, if you know a little better with the bearings.
Yes, sir.
Okay,
So,
great.
so one question.
Tell
So
me.
one question. So I don't get how it is 140 from the top.
All right. So let me run this back from the top, right? So Ivan, do you understand how we get the 40, right? Understand that part?
Yes.
All right. So we start off from K. So that was point K. So we have an outline. From K, we end up reaching L. So this is another point, right? So Ivan, I'm going to put down a note line at L. You with me so far?
Yes, sir.
Okay. So tell me, Ivan, what is the sum of angles about a line?
So 180.
Right, 180. So if this is 40 degrees, what do you think this would be?
140.
Right. And we know that this is 180 over here.
Yeah.
So how would I figure out for this missing angle here then?
So take away 180 from 40.
I think you mean to say 140 from 180. Let me run that back one more time. Say, understand this could be 140, right?
Right, yeah.
And you know this whole thing here will be 180, yeah?
Yeah, all right.
So this missing angle would have to be 40 degrees. I would say 180 minus 140. Because the sum of angles on our line is 180. So if there's 140 here, it's got to be 40 to get me back 180. You understand?
Yeah.
Right. All right, so Ivan, I hear a lot of noise in the background. You can please mute your mic?
Oh, all right.
Yes. So guys, we're going to move on to something very juicy, right? And it's not KFC. Although, I wish I could have eat some KFC now. Anybody want to sponsor KFC? Can I feel hungry? Any sponsors?
Yes, it's a KFC.
Say that again.
So I ate KFC this morning.
You're not making my food. I don't know. I want some KFC. That's what I'm saying. I want somebody to sponsor KFC. But anyways, let's move on. Let's move on to this something called the cosine rule. I love the cosine rule. So the cosine rule is just a fancy version of Pythagoras theorem. You all remember Pythagoras theorem? Do you all know what Pythagoras theorem is? I feel like some of you all here.
I can answer.
Yeah, you
Yes,
can.
sir.
A square equal B square plus C square.
Right. So I want you to keep this in mind, right? So the cosine rule, right, is a more general form of Pythagoras' theorem. Now let me explain why I'm saying that, right? Guys, people in my Form 5 class, Pythagoras theorem only works for what type of triangles?
Right angle triangles.
Right. Pythagoras' theorem only works if you have a right angle triangle. Only works if you have a right angle triangle. That's the only time this is working. And Pythagoras theorem allows us to figure out, allows us to find allows us to find the length of one side provided you know the other two lengths. So guys, what I'm trying to say is Pythagoras theorem, it only works if you have a right angle triangle. If you don't know what a right angle triangle does look like, it looks like this, right? It must have this little box to the side indicating it's a right angle. A right angle means 90 degrees for anybody that looking and is confused, right? So let's look at the second statement. So Sanjay, hence we know the Pythagoras theorem only allows us to find the length of one side, and for you to figure that out, then you need two other sides.
Yes, sir.
Right, and we know Pythagoras theorem is look like this. A squared is equal to b squared plus c squared, yeah?
Yes, sir.
Right, let's zip over to the cosine rule, which is my dog. I love the cosine rule back. You go see the similarities between cosine and Pythagoras. Now, first things first, cosine rule is very similar to Pythagoras theorem, real similar. You need two sides, and not just two sides. You need, I'm going to be very specific here. You need an included angle. You need an included angle. And for something to be an included angle, you must have two sides next to the angle. See what I mean by that just now, right? So Sanjay, when you're using the cosine rule, you need two sides. You need two sides. And it allows you to find the length of the side opposite the included angle. All of this will make sense very, very, very shortly, right? Allows us to find the length of the side opposite the included angle. Okay, and time for us to actually write down the cosine rule. So the cosine rule looks like a squared is equal to b squared plus c squared. Guys, doesn't that look a little familiar? A little familiar? I can't be the only one that find that look familiar. Sanjay, and that look real familiar?
Yes, sir.
Well, I'm going to continue. Minus 2bc cosine e. Isn't this part literally just from the Pythagoras theorem? Literally. Isn't that just from the Pythagoras theorem? A squared is equal to b squared plus c squared. Watch. See what I'm talking about? I have a huge similarity there. Right. Let's see what I'm talking about, the similarity. Because Pythagoras theorem is a squared is equal to b squared plus c squared. And cosine rule is a squared is equal to b squared plus c squared minus 2bc cosine e. But the thing is, the cosine rule works with any triangle. It's not such like the Pythagoras theorem. It will work with any triangle. If it's 90, if it's not 90, everything will work. Right? Nice. So I guess you could think about Pythagoras theorem. No, I was going to make a joke. Are they want to hear the joke? Are they want to hear it or not?
Yes, sir.
Of course, sir.
Okay. So Pythagoras theorem kind of stush. Kind of like, okay, until you know it have like a red girl rumor. You know, like red girl real stush. That's what I know what I'm talking about. But anyways, some people very stush like Pythagoras theorem, and the cosine rule will work for any angle. So let me show you an example. Before you could understand cosine rule, you need to understand how to label the triangles. How that turn into a square? I want to say square. How that turn into a rectangle? Bro, what? Somebody needs to get fired in good notes. I don't know what they're doing over there. So Shana, you there?
Yes, sir.
All right, so Shana, when you're dealing with triangles that are not 90 degrees, okay, they're looking like 90 degrees. I'm gonna fix that. Anytime you're dealing with triangles that are not 90 degrees, you're not gonna label it the hypotenuse, opposite, adjacent, right? By the way, you ever do Pythagoras theorem before?
Yes, sir.
Okay, good. So when we're dealing with these types of triangles, this is what we're gonna do. So I'm gonna call this A, I'm gonna call this B, and I'm gonna call this C. Anytime you see me write capital letters, just know I'm referring to angles. That's what I'm doing. I'm referring to angles, right? I'm referring to angles. If you see me talk about common letters, just know I'm talking about lengths. Common letters, I'm talking about lengths. So check this, right?
Yes, sir.
So Shayna, if this is angle A over here, then the side opposite to it, I would call that side common A. If this is angle C over here, what do you think I'd call the opposite side?
C. Come on, C.
And if this is angle B, what do you think I'll call this side?
Come on, C. Come on, B.
Common B. Guys, do you all understand how we label triangles that are not 90 degrees? You need to understand this labeling structure. Ivan, I see you writing on the screen. Can you abstain from that? Can I write on the screen? Right. Is there anybody that does not understand how to label triangles that are not 90 degrees? Adika, are you still here?
Yeah, I saw you.
Okay, we still outside. But no, that's a wrong statement to make because we inside. You're inside, right? Aren't you doing work?
Yeah, inside here.
Okay, good. So, you ever do Pythagoras theorem before? Or trig ratios with right angle triangles?
Yeah, but I never really understand it before today.
Shucks. Well, today we're gonna move above that. We're gonna look at triangles that are not 90 degrees. So I feel like I want you to stay with me, right? Do you understand how I label this triangle?
Yeah.
Okay, let's do another example, right? Let's do another example. First things first, Adika. Does that look like a right angle triangle?
No.
No. So we use cosine and sine rule when we're dealing with triangles that are not 90-degree angle triangles. So let me call this J, H, and K. So tell me, Adika, if this is angle J, this is angle H, and this is angle K, can you tell me what I'd call this side?
Like, what do you mean, like, come on, Jay?
Yes.
Like that? Or like,
Exactly. This is common J. It was gonna say HK. It was gonna say HK.
yeah.
Okay. Tell me, what would I call this side? What would I call this side? This side over here. What would I call this?
Come on, H.
Right? Common H. Great. And if this is angle K, what would I call this side?
It'll be come on, K.
Common K. Nice. So let me show you all an application of the cosine rule. All right? Let me show you our application. So this is the general formula. So let me come up with a triangle. I'm going to draw a triangle here. I'm going to draw a real wonky triangle. All right. I want some volunteers. I want a little Telma. So I'm going to call that A. I'm going to call that B. I'm going to call that C. Right? What angle are looking like? Somebody give me an angle. Anything. Give me an angle. What angle is that looking?
30,
Angle what? Like how much degrees?
30, 30.
30 degrees. Okay. Let me just say that's 30 degrees, right? Let me just say it's 30 degrees. Let me just say I know that this length is 7 centimeters. And guys, if I'm saying this is 7 centimeters, how much do you think this could be? Make a rough estimate.
$11
Okay,
or
11.
12.
All right. So I want to bring something to all your attention, right? You see how we have an angle here? And you know the lengths right next to it, the adjacent lengths? You see that? You see that, right? Let's see what I'm talking about. You have an angle, and you know the two lengths right next to it. Yeah or no?
Yes, sir.
All right. This you would say, okay, since we know the lengths on either side of the 30 degrees, we would say angle A is an included angle. So, Adika, do you think you understand what an included angle is? We need to start off with that. You need to understand what included angle is.
Yeah.
All right. So you could only use cosine rule when you have an included angle. That's a big hack, right? I think teachers will gatekeep that, right? Somebody said with the adjacents, yes, right? So an angle is included if you know the adjacent sides, right? Adjacent is a fancy word for right next to, next to. Great. So anytime you have an included angle, you know what I mean, Adika? Anytime you have an included angle, you can use cosine rule. Because Adika, I sure self when you was doing trig ratios and thing, it was like, oh God, when I had to use sine, cosine and thing, you was probably wondering that, like, okay, when am I going to use sine, cosine, and tan? And you had problems trying to figure out which one to use?
Yeah, I used to go back to the front of the page, me possible.
All right. Well,
So,
yeah, Ivan.
what is the included angle again?
Okay, an included angle is an angle who you know the adjacent. Okay, I'll show you another example, right? But basically, is an angle whose lengths you know on either side. So you see how we have 30 degrees over here, and we know that this is 7 and this is 11.
Yeah.
That means 30 is an included angle, right? Let me show you something that is not an included angle. Check this. Let me just say J, H, and K, right? Let me just say we have angle H, and angle H is 38 degrees. Let's just say we had 5 centimeters and 8 centimeters. So, Ivan, do we know the length of the two adjacent sides right next to 38 degrees? Tell me, Ivan.
Yes, sir.
No, we don't.
Yes, sir.
Do we know what this length is?
No.
No, so it's not included angle. For an angle to be included, it needs to be between two known sides. If it's not between two known sides, it's not an included angle. So this is not an included angle. Not. So say angle H. Angle H is not an included angle. Okay, Ivan, let me give you another one, right? And you'll see if you can figure this one out. C, D, E. So Ivan, let's just say I give you this angle here, 89 degrees. And I tell you that this is 10 centimeters here. And I tell you that this is 9 centimeters here. Is angle C an included angle?
Yes, sir.
No. Again, Ivan, an angle is included if you know the length on either side. So Ivan,
Oh,
89 degrees,
oh, I.
yeah, 89 degrees is over there, right? For it to be included, you need to know the length of CE, but you don't. You don't.
Oh, oh.
No, anytime you have an included angle, you use cosine. You use the cosine rule. If you're referring to this specific example, yes, you'd have to use sine rule. But anytime you have an included angle, you use the cosine rule. Right, Ivan? So this is not an included angle. Ivan, you know what they say to times the charm. So try to redeem yourself. Right? X, Y, Z. So let's just say we have an angle 70 degrees. Let me just say that this is 9 centimeters and this is 8 centimeters. Tell me, Ivan, is angle Y an included angle?
No, sir.
It is an included angle. Ivan, why you say no?
Because I said, sir, I just,
All right, so
I don't
Ivan,
know.
an included angle is an angle whose lengths on either side we know. So Ivan, if this is 70 degrees here, what are the sides next to that angle? Ivan?
So, 8 and 9.
8 and 9. Yes. So Ivan, do we know the lengths of the sides right next to the angle?
Yes, sir. We know.
Yes. That makes it an included angle. So I'll make a little note about it here. Make a little note about it here. If you know the lengths on either side of an angle, it is said to be included. And I guess it's a way to remember it, right? If it between two sides is included, it's included between those sides, right? So Ivan, I'm going to give you one more example and please redeem it. I think you could do it. I think you could do it, right? Yes, yes, the person on the chat, when it's not included, you use the sign rule, right? Right, so Ivan, let me just say that this is 100 degrees. Let's just say that this length is 5 centimeters and this length is 1 centimeter. Now, Ivan, before you tell me your answer, right? Ivan, before you tell me your answer, what's the angle we're looking at in this question? Look
So,
at it.
angle J.
100, right? 100. Tell me, Ivan, what are the sides next to the 100 degrees?
So, T and M.
T and M.
T and M.
Wait, okay. I'll help you here, right? TI is one side, give another side. So TI is one side next to the angle, give another side. That's next to the angle.
I and M.
Yes, I am. So tell me, right? Do we know the lengths of both TI and IM? Think carefully before you tell me your answer.
No, sir.
No. Which length do we have? We have length TI or IM?
TI.
Right. But for this to be an included angle, you would need to know what IM is. Understand?
Right.
Nice. So this is not an included angle. Let's do one more. I keep saying one more, but this genuinely will be the last one. All right. And so Ivan, let's just say that this is 95 degrees. Let's just say we know that LM is 3 centimeters, and let's just say MN is 10 centimeters. Would I say that this is an included angle? Now, Ivan, before I tell my answer,
Yes, sir.
You said yes?
Yes, sir.
Yes, it would be an included angle. Big up yourself, right? Big up yourself. So, Ivan, let's try to understand why we say that. If you look at this side and this side, aren't those the sides that are next to the angle? Watch. you see what I'm talking about?
Yes, sir.
So Ivan, tell me, what are the lengths right next to the angle? Tell me the lengths. So I'll start you off, right? This LM, and which other length?
M and N.
Right. So Ivan, and we know what LM and MN is? And we know that?
Yes, sir.
Yeah, so once you know the lengths that are right next to the angle, it's an included angle, and you could use cosine rule. That's the whole gist of cosine rule. So angle M is an included angle because we know the lengths of the sides adjacent to it. And adjacent just means next to. Okay, everybody in the Zoom meeting, are you all okay with recognizing included angles now? Let me know, guys. Adika, Camille,
Yeah,
Perseus, Shina, Sanjay,
Yes, sir.
Yes, sir.
right? Kylie, I see you join. Kylie, you good? I swear I see you for a second. I start seeing things. Okay. All right, let me continue. So I'm going to take it that all of us can recognize what an included angle is now. So let's actually attack this question. So Darius, how are you helping me with this question, right, Darius? So Darius, would you say that angle A is an included angle?
Yes, sir.
I would say that. And why would you say that? Why would you say it's an included angle?
Because you have the lengths of the adjacent sides.
Yes. I know this is 7 and I know this is 11. Nice. Great job. So next thing we're going to do is we're going to label this triangle. We need to label it using the same convention that I taught you all earlier today. Right. Okay. look the Titanic thing pop up again. That's an inside joke from now on. Right. Great. So Darius, let me attack this question now. Right. So
Sir.
Darius, if this is angle A, what would I make this side?
Common A.
Right. Ivan, if this Ivan, if this is angle B over here, what would I make this side, Ivan?
So the hypotenuse.
No, Ivan, when we're dealing with triangles that do have 90 degrees on them, forget about the hypotenuse, adjacent, opposites. We're not using that naming convention, right? So Ivan, how this is work, right?
Oh.
Check this. If this is angle A, then opposite to angle A would be side common A. If this is angle B, opposite angle B would be side common B. That's the naming convention here we're going to use, right? And Ivan, you use this anytime you're dealing with triangles that are not 90 degrees, right? So Ivan, you seen any 90 degrees in that triangle?
So no.
Nah, so you're not going to use opposite, hypotenuse, adjacent, none of that, right? Guys, tell me, what would I call this length? What would I call this length? Somebody tell me, what would I call this length?
AB.
Nah, using naming convention. Using naming convention for this topic. If this is angle C,
C.
common C, right? We'd call this common C. So guys, let's run through the criteria. I need to use cosine rule. For me to use cosine rule, I must have an included angle. Must have included angle. Guys, do we have an included angle? Just remind me, do we have an included angle?
30 degrees.
Yes. the 30 degrees. That's the included angle. So I want to write a more general formula for cosine rule. I'm gonna write a more general formula, right? Side opposite included angle squared. And this will make your life so simple, right? Other side squared plus other side, wait, adjacent side squared minus 2 by adjacent side by adjacent side. I'm writing this because a lot of students have a hard time using the cosine rule. But this is a very, very, very general formula. So the side opposite the included angle squared is equal to the adjacent side squared plus the adjacent side squared minus 2 adjacent side by adjacent side cosine the included angle. After this, you shouldn't have problems at all using the cosine rule. So Darius, let's actually interpret the formula, right? So Darius, the formula says the side opposite included angle squared. So what's the side opposite the included angle here?
Common A squared.
Right, so we're gonna write A squared, right? What is one of the adjacent sides? What is one of the adjacent sides in this diagram?
7.
7. Let me write the formula first, right? So I could write
Right.
C squared if I want, right? Another adjacent side is B squared, right? Then we could say minus 2. We're multiplying tell me, where's an adjacent side?
C and B.
Right? C and B, so you're going to say 2C by B, right? And what's the
A.
A, right? Great. So Sanjay, do you know about the cosine rule?
Yes, sir.
Okay. Let me explain what's right in here, what I wrote here, right? I'm saying the side opposite the included angle. So if this is the included angle here, what's the side opposite to that? Tell me, Sanjay, if this is the included angle, what's the side opposite to it?
Like next to it or opposite? Like directly opposite?
Directly opposite.
Oh, E.
E, right?
E common E.
Right? So that's why we put E squared over here. And then we're gonna have the adjacent sides squared, I'm gonna add them. So enter adjacent side is 7. So I could say 7 squared if I wanted. Right?
Yes, sir.
So adjacent side just means the sides next to the angle. Right? So adjacent side squared plus adjacent side squared minus 2 times the adjacent side by the adjacent side cos of the included angle. So let's actually plug things in and get an answer, right? So Darius, do we know what common A is?
No, sir.
No, so I'm going to leave that blank for now. Do I know what common C is?
Yes, sir.
Right, that's going to be 7 squared.
7 squared.
Right, and what's B? What's common B?
And 11 squared.
Right, minus 2. What is C?
7.
What is B?
Multiplied by 11.
Right, then cos was the included angle.
30.
Great. Now, guys, I understand that some of you all don't have a Casio. So in that case, I would advise to plug this into the calculator, right? And then find the square root of the answer. But if you do have a Casio, let me show you how easy it's going to be. Wait, So, Darius, if this is A squared, right? I want to find for what? What do I want to find for? Do I want to find for A squared or do I want to find for A? So if I want to find for A, I'd have to square root both sides, right?
Yes, sir.
Yeah, so if you have a Casio, it's very easy to plug this entire expression into the calculator. But don't worry, guys, I'll cater for everybody, right? But let me just do the Casio side of things first. So in the Casio, you're going to press the square root button. Then you're going to put 7 squared plus 11 squared, right? Minus 2, open bracket, 7, close bracket, open bracket, 11, right? Then cos included angle here is 30. Then press equal, you should get 6.05. Let me know if you'll get 6.05. Those are the Casio.
So 12.09.
You have a Casio?
Yes, sir.
That's weird. Let me run through the working step by step, right? So do the exact same thing I
Oh,
did.
sir, I forgot what calculator and radians.
Oh, is you add maths?
Yeah.
Okay, I'll do some odd maths. I'll do some odd maths and physics live soon, right? But like I know everybody is doing math, so this is like my best live to be benefiting everybody, right? But I want to do our odd maths live soon. All right. Yeah, so do it back and you should get a 6.05. Right?
Yes, sir, I got that.
So guys, this is what I would recommend doing if you have a Casio, right? If you have a Casio, by all means, just plug this into the calculator. If you have a Casio, if you have a Casio, I'm gonna assume most of you all in class here don't have a Casio. Right? Adika, do you have a Casio?
No, not yet.
All right. Let me show you how to attack this question. So in the calculator, you're gonna put 7 squared. So tell me if you're with me, right? Put 7 squared,
Yeah,
then plus 11 squared
yeah,
minus 2, open bracket, 7, close bracket,
yeah,
then another open bracket, 11, close bracket.
yeah,
Then you're gonna press cos,
yeah,
then you're gonna put 30 on the inside. Then I want you to press equal.
yeah. I get an answer.
Right. I want you to, to clear your calculator,
Yeah.
like temporarily, not like take off your calculator or anything, just clear the screen. You know how to clear the screen?
Oh, no.
No? Care what to do with your answer, right? I want you to press, now, you're not doing hard maths. I'm gonna take you not doing hard maths, right? Is you hard maths?
Okay.
You just do hard
No.
maths. Oh, all right. Square root is the same thing as raising something to the power of a half. So let me show you what you can do next. Do you have the X star power button?
Yeah,
Okay, press that button.
I think so. Daddy X squared or DYX button?
Wait, I have a sharp here. Sharp calculator, so ugly. I don't like sharp. But you'll have to press. Wait, okay, you will have to press the Y to the X button. You have a Y to the X button in the calculator.
Yeah,
All right, press that.
yeah,
Right, then open a bracket. Actually,
yeah.
take off the bracket, right? Just put 0.5. Just put 0.5. And it should get 6.05.
I get it. Yeah,
Okay,
I get it.
nice. So let me explain what happened in there, right, Adika? So you see that 36 point something you got?
Yeah.
That is what you got over here, right? So that was what a squared would be equal to. A squared was equal to 36 point whatever. But do you think we want to find for a squared, or do you think we want to find for e?
We want to find for A.
Right. So do
It's
you know what the opposite of squaring something is?
um no,
Square root and something.
divided.
No, square root and something. Square root. Or raising something to the power of a half. That's the opposite, that's the inverse operation of squaring something. Yeah. I feel like I confused you real badly. Don't worry, I will explain it just now. Give me a second.
Okay.
Let me just explain that in a way you understand. Right. So if I had 4 squared, what does that mean? What is 4 squared?
Yeah. 4 by 4.
Right, 4 by 4. And that would give me what?
16.
16, right? 16. Now,
Yeah.
what if you wanted to undo the squaring process and get back 4? That's where square roots would come in. If you find the square root of 16, do you know what that would be equal to? You know what square root does? Is that safe space? Tell me, do you know what?
Divided.
No, that's not what square root does. Square root asks the calculator what number by itself would give me 16. So can you think of 2 numbers you can multiply to get back 16? 2 are the same numbers, that'd be the same number. Let me start off, right? If you say
16 and 1.
no, I tell you, they have to be the exact same number. That's why we call it square.
Oh.
So let me, 1 by 1 is 1. How about 2 by 2? What's 2 by 2?
4.
Okay, what about 3 by 3?
9.
What about 4 by 4?
16.
Oh, so you see, that's what square rooters do. The square root is asking the calculator what number by itself will give me back the input. So if I put 16 into the square root, right, I'm going to get 4 because 4 squared would give me 16. You understand?
Yeah.
So again, I'm going to run through that one more time. So 4 squared would be 16, right? Let's just say I wanted to get back the number here. I would do the square root of 16 and that would give me the number. Because the square root allows us to figure out what number by itself would give me the number. So let me give you another example. What about the square root of 9? What do you think the square root of 9 is?
3.
3, right? You'd say 3. Great. And if you found 3 squared, what would 3 squared be?
It will be 9.
Right. Can you see how raising something to the power 2 and square rooting it are the opposites?
Yeah.
Again, let me understand that. If I find the square root of 9, what again?
You'll get 3.
And if I find the square of 3, what again?
9.
Right. You see how it's like the opposites of each other?
Yeah.
So watch what I'm saying, right? Watch what I'm saying. If I find the square root on either side, okay, and we know 3 squared is 9. We know 3 squared is 9.
Yeah.
Okay. So if I find the square roots on both sides, what number by itself would give me back 9?
3.
3. So you see how this square root gets rid of the square and it gives you back 3?
Yeah.
Watch that closely. Let me get another example. Let me just say we have 8 squared is equal to 64. If I found the square root on both sides, tell me something, right? Right, Adika? What number by itself would give you
Yeah.
back 64? What by what is 64?
8.
The answer right here, right? 8. So by finding
Yeah.
the square root of that, it gets rid of the square, and that would give you just 8. So do you understand that the square root gets rid of the square?
Yeah.
Nice. So great. That's very important. I understand that. So anytime I ask you what is the inverse operation of square root of squaring something, they tell me square root. So square rooting something is the opposite of squaring something. Understand?
All right. Yeah.
So this is the general rule. The square root of a squared would give me e. What do you think the square root of b squared would give you?
B.
Yeah, right? Great. So for those that have a sharp, I would recommend plugging this into the calculator. And when you do that, you're supposed to get,
Excuse me, sir.
yes, Tama.
So we plug in it in just as, right?
You have
So,
a,
or
you have
are
a
we
sharp or a
going
casting.
to? I have a shop.
Okay, if you have a sharp, you have to be real careful what you're doing.
Because to get this final answer, I press second function to get the square root now. I press second function, the x squared, and plugged everything in.
Okay, great. For those that have a sharp, okay, so Camille, you see, that's fine, but when students do that, for some reason, let me show you what has happened. On a sharp, right? And the square root sign don't cover everything. Like,
The
let me show
square
you,
root sign what?
it doesn't cover everything. So like,
Okay.
let me see if I could plug this into a sharp. Yeah, I wouldn't be able to do that. But with the sharp, okay. Watch this, right? So, Camille, can you see how the square root sign covers every single thing in the Casio calculator?
Yeah.
The sharp doesn't do that, and that
So I'm
confuses
gonna
me.
do it and send a picture. I'm gonna do it and send a picture on
I know,
WhatsApp, right?
I know exactly where you do. But you put brackets, or you didn't put on brackets.
So I plugged it in exactly how it is here.
And they get through.
But I'm gonna do it and send a picture, right?
All right, nice.
Right.
Dika, you had a sharp, right?
Yeah.
Okay, let me see if it will work out, right? So I want you to press the square root button. Press the square root button.
It wasn't working.
Say that again.
It wasn't working. When I was trying, it was just covering the first number.
Don't worry. The sharp is very weird. That's how it is work. I tell you, real. Sharp is the worst kind of calculator, honestly. But just trust me, right? Just trust me. So on the sharp, I want you to press the square root button. To get the square root button, for some weird reason, you have to press second function x squared. So you have the square root button in the calculator.
Yeah.
Okay. You're gonna put 7 squared plus 11 squared. At no point do I want you to press the right arrow. Don't come out of the square root sign. Right? Don't come out of the square root sign.
Wait, just a
It's looking like it's not in the square root sign, but it is. Just stay within the square root sign.
all right. So
Right? So 7 squared plus 11 squared, then minus 2, open bracket, 7, close bracket, open bracket, 11, close bracket, cos 30, close bracket. Press equal and you're supposed to get the answer.
just
You will let me know if you get the answer.
I get minus 5.36.
Okay, let me show you a sure way to get the answer, right?
Yeah, I got that as well.
All right, guys, watch this, right? The sharp calculator is really, really dumb. So let me show you a way to counteract the dumbness of a sharp calculator. So everybody press the square root button, right? Press the square root button. Then I want you to
Yeah.
press open brackets, open bracket, right? Then you're going to press 7 squared, right?
Yeah.
Plus 11 squared, right?
Yeah.
Minus 2, open bracket, 7, close bracket, open bracket, 11, close bracket, then cos 30, close bracket, and then put another close bracket. Sean, if you have a Casio, it's real simple.
Yeah, I get the answer.
Sean, if you have a Casio, it's extremely simple. With a sharp, you really have to know how to use BODMAS and brackets. You could do it one step at a time, but you're going to end up with rounding errors. And that's not ideal. So, did both of you guys get your answer?
Yeah, I get the answer.
Okay, 6.0524448. Nice. So guys, with the sharp, what has happened is sometimes it doesn't fully recognize that everything is inside the square root sign. You have to be very careful. Right. But I was saying, if you have a sharp, what you could also do is you could just work out it, you could just work out the right-hand side, right? You could work out the right-hand side, right? And you'll get to the 6.6320878 and then you could find the square root on both sides, and you'll get an answer. Or you could just plug the whole thing into the calculator, right? And when you plug the whole thing into the calculator, you're supposed to get, the 6.05 answer, right? And that would be in centimeters. Right, Darius, you understand that question?
Yes, sir.
All right. So guys, let's understand the procedure one more time. You use the cosine rule when you have an included angle. If you don't have an included angle, chances are you will have to use the sine rule, right? Keep that in mind. Next thing, this is the most general formula of the cosine rule out there. So Darius, let me run through the formula one more time, right? So the formula always starts off with the side opposite the included angle. So Darius, in this question, what was the side opposite the included angle?
A.
A, right? And then you're gonna have the adjacent sides squared and you're gonna add them. So the adjacent sides here was C and B. So I said C, B. What's saying? I said C, B. Tell me if you understand what I'm saying, Darius. So the adjacent
Yes,
side
sir.
were right next to the angle. So they were C and B. Then minus 2, and you're going to multiply the adjacent sides. So this is one of the adjacent sides, C, and B is one of the adjacent sides as well. So you're going to say C by B. And then it's cosine of the included angle. The included angle is the angle that is in between the two known sides. Right. So I want you all to take a screenshot of this. Right? Take a screenshot of this, guys. And I'm going to move on to another question. And I'm going to change up the sides.
So one question, right?
Yeah.
Okay, just like you see how you were saying, like people with Casio and sharp, right? Like people with Casio will get the answer like as soon as they plug it in. If like for exam, right, like realistically, like if I just plug in the terms just how it is into my calculator and put the answer like that, would I lose marks for like not having the other two lines?
Here is my advice, right? They can't take away marks, but you need to show the fact that you found the square root. So let me show you what I mean by that. So you see how we have this line here? Yeah, you see how we
Yes,
have
sir.
put a square root on both sides to show them that you knew that you had to apply square root. And then in the next line, you can say the final answer. Because what is the square root of a squared?
A.
E. And You could plug this into the calculator and you'll get your answer. So that's my advice, right? Put the square root
Okay,
sign
sir.
side to show them that you know you were supposed to find the square root on both sides. Guys,
Okay, sir.
if you want access to the notes, just send me a message on WhatsApp, right? Go into my account, follow, of course, and you should see my number there. Just send me a message. I'll send you the notes from today. All right. Okay. So I'm going to move on to our next question, right, guys? Next question. I see it's 10:07. I'll do some couple more questions and then I'll call it a night. Right. So I'm gonna write back down this formula. Eventually, you will be able to remember this formula by heart, and you'll see it's a general pattern. Okay. So Darius, let me go again, right? All right. So Darius, let's call this G, K, and M. Let's just say angle J is 37 degrees. Let's just say that this side here is 9 centimeters and this side is 7 centimeters. First things first, guys, are you all seeing an included angle? Let me know, guys, are you all seeing an included angle there? Nicolette, yes, your answer is correct. People in the Zoom, are they seeing an included angle?
Yes, sir.
Yeah, I'm seeing an included angle, right? What's the included angle here?
The included angle is 37 degrees.
It is 37 degrees, right? So let's label our sides now. If this is angle J, what would this side be?
J,
Come on, J. If this is angle K, what would I call this side?
common key.
Come on, K. What would I call this side?
Common M.
Come on, M, right? Okay, guys. So let's write down our formula first. You love to see this. So Darius, what is the side opposite the included angle?
The side opposite the included angle is common J.
Right? So we're going to write J squared. And then we're going to put the adjacent sides, we're going to add them and square them, right? So tell me, Darius, what are the adjacent sides?
K and M.
We're going to write K squared plus
K squared and M squared.
minus 2 what?
2 km.
And what's the included angle?
Cos the angle J, which is 37.
Right, so Darius, you see in a pattern here, watch. You're starting off with the
Yes,
included,
sir.
and you're ending off with the included angle, and then you have the adjacent sides there, and then the adjacent sides here. So like, it's really not that hard. It only looking real complicated, but I promise it's not that hard. Right?
Yes,
Right.
sir.
So let's plug in everything now. So tell me, Darius, what is key? This key.
9 centimeters.
So we're gonna write 9 squared. What's M?
9 squared. 7 squared.
Right? What is K?
Minus
Now,
9.
K is 9. What is M?
7.
Right? And what's the included angle?
37.
Nice. So here what we're gonna do, right? What you can do is you could put the square root sign on either side, right? You could put the square root sign on.
Sir,
Yeah, Talma.
what will work it out?
Say that again.
Work it out? Like put it in the calculator?
Yes. But before we do that, right?
Okay, sir.
Adika, are you there? Adika, let me know if you're there. kind of heard from Adika, right? But Darius, do you think you understood why I found the square root of j squared?
Yes, sir.
Because I was trying to find for what?
You was trying to find for j, and in the formula I have j squared, so you need j by itself, so you just square it.
Right, because the square root, okay, the square root is the opposite function to square in something. So if you put them on top of each other, they cancel, right? So you're gonna plug this into your calculator. Now, this is what Casio users are going to do. Casio users. If you have a sharp, this is what you're going to do. And this is how it will look like in the calculator. So everybody with a sharp, this is what you're gonna do. Sharp users. You're gonna open up a bracket. You're gonna put 9 squared. Wait, give me a second. I have a sharp over here, but it dead. And I need like the lights. That's crazy, right, guys? 1 second. All right. Yeah, so in the sharp, you're gonna open a bracket, the 9 squared plus 7 squared, all right, minus 2 by 9 by 7 cos 37. Then you're gonna close the bracket. So if you have a Casio, right, you could plug this exactly the way you're seeing it. If you have a sharp, this is where you're gonna plug in, right? So guys, what are you getting for your answer?
$5.41.
Let's verify that. Let's verify that. I'm not saying you're wrong. I just want to verify that. I never sharp or a Casio. You really want with the sharp?
Yeah, sharp.
All right, let's verify that. 9 squared plus 7 squared minus 2 by 9. I tell you now, if I was rich enough, I would have just give Casio calculators for free. Or I'll be doing Lord's work. Right? But yes, you are correct. But guys, be very careful here. In CSEC, they usually want you to round off to 2 decimal places. So that's going to be 5.42. Why am I saying that? Well, that's why I'm saying that. Watch. If I write out the full thing, 5.419587229. Adika, what is my second decimal place? If you look at this, what's your second decimal place?
1.
I get like PTSD there, boy. Please. I get PTSD. All right. Darius, what's the second decimal place here?
1.
1, right? This is the first, this is the second. What's the
Yes,
number?
sir. 1.
Number after 1. What's the number after 1?
Like
9.
in the answer, like
9 is the number after 1, right? So since 9 is 5 or more,
yes, sir.
you will take 1 and add 1 to it. So that's going to be 5.42. So everybody that said 5.41, if you're strictly rounding off to 2 decimal places, your answer is wrong. It should be 5.42, right? To 2 decimal places. Nice. Is everybody okay with this?
Yeah.
All right.
Yes,
Again,
sir.
Yes, sir. The method that you show us with the sharp users, yeah, even though you're being a little biased, sir, but it's all right.
okay. Oh, wait. I just stand up for this one. Let me just stretch my back. Oh, okay. I had to stretch it out. Hear this, right? Let me tell you a little story. Okay. Ever since I go in secondary school, right? I was using a sharp. I still had the sharp I used to use all the way up until upper 6. So it's not like I being biased, I talking from experience because the day for my paper 1 pure maths exam, I borrow my sister Cassie. Keep in mind, my sister is a business student. She should be the one having the shop. I should have the Casio. And I was able to figure out 90% of the whole paper using a Casio. You would not be able to do that with a sharp. You would catch a tail with a sharp. Look at it. This is the sharp I had since Form 1. So I'm not being biased, I'm just being real. All right, Camille? I'm being real. You can see that is Casio. I mean that is sharp.
Sorry, I just pull on your leg. I pull on your leg.
I'm telling you, yeah.
Pull on your leg. I was persuaded enough to go and get a Casio.
That's good.
Because it could be a little tricky. Yeah.
You see what and the Casio, look how much functions the Casio has. It has calculator mode, complex mode, base N, matrices, spreadsheets, distribution, statistics, vectors, tables, equations. It can solve equations for you, inequalities, ratios. I'm telling all them, get a Casio. Get a Casio. I'm going to start to make videos on my page showing all them how to use the Casio. So follow the TikTok. If you're not already following the TikTok, what you're doing? Right? Follow the TikTok. I'm gonna be posting some lives soon.
So we could go into our paper 2 exams with the Casio, right?
Yes. No. Yes. Yes, you can go in. Yes.
Alright.
You can't stop. Right? If they stop you, throw some punches. They'll actually do that, eh? But what I would do is I would take the rules and show them. I would read the rules to the examiners and I'd tell them there's nothing here that stipulates that I can't have a Casio. You just want to see me fail. That's what you want to do. You just want to see me fail. Right? Guys, if they tell all the Cayuse or the Casio, or they could report that invigilator to the Ministry of Education, they could get fired. Right? So nobody could tell you all the Cayuse or the Casio. You could. You have a right to use a Casio. In Casio, we trust. In Casio, we trust. Then after is Rajiv, we trust. Right? I feel like Casio is better than me. Casio saves lives. It does. It really does. Especially if you're doing hard maths or pure maths or like higher level maths. Get a Casio. But anyways, Camille, you want to do a question from scratch now? I want to give either you or Adika to do a question. So like pick amongst yourselves. Which one of you guys want to take the question? Because see Perseus,
Which one?
Sir, no, sir. I have to leave. I have to leave now.
Oh, I will.
But I start to give.
Boy, I will say go and do a question with me. Well, I get excited, you know. But that is okay. I'm sorry to hear your eyes hurting you. Go and take some rest. You was looking at the screen for a long time. It was good having you. Thank you for staying for so long. I hope you learned some stuff.
Sir, doing a live tomorrow, please go, right?
Yeah, for sure. If I get the time, do a live.
Okay, I'll be there.
Nice.
Night, sir. Night,
Good night. Yeah, so Adika and Camille, pick amongst yourselves. Which one of you all would like to take our next question? We're gonna do another question. Which one all they want to try the question?
All right. I'll go for it.
I like
don't know
this.
if Adika want to.
Adika.
I could go ahead and go.
Are they fighting to do? Okay, I like this. I like what I see. I like fighting. All right, so Adika, let me do the first question, and then Camille will do another question, right?
All right.
Okay. Camille, I'm saying that because every time you're on mute, for some reason, I hear it myself. I have a real echo, like a real. I don't know why. I have a real echo. Like
So I don't know. I had it connected to my speaker because I'm literally like close up in front of my laptop because it's sounding so soft. Oh, I don't know. Probably because of the area it's enclosed. I don't know.
wait, let me try to boost the loudness. Give me a second. Sound check 1 1. Sound check. Can you hear me better now? Yeah, me better now?
Yeah.
Okay, cool. Right, so Adika, let me go. Let me do a question. So Adika, give me 2 random letters. Adika, give me
A and K.
three, yeah? Three random letters, not
Okay. And T.
A, K, and T.
Yeah.
Okay. So just go and say 14. I don't know if it's true, but I swear to God, I surprised TikTok didn't take down my life. I so surprised. I so surprised. But anyways, let me continue. My humor real crazy. Um, yeah. So Adika, I want you to pick an angle. Give me an angle. Give me an angle, either A, K, or T. Give me an angle.
A.
All right. What our angle looking like?
Like 60.
60. All right. Um, give me the lengths for the two adjacent sides, and I want you to tell me what the two adjacent sides are.
Okay. It could be any number.
Yeah, any number.
All right. So for A, we go for 19.
All right.
And for AT, we could put 8.
Okay, you doing yo. Okay, let me look at the diagram. Let me look at the diagram here. Let me let me look at the diagram. It was 19, right? Now, just by looking at the diagram, they're looking kind of the same. So
Oh,
yeah.
yeah.
So think of something like closer to 19. And looking at a little less than 19.
Okay, 18 or 17.
Use 18, right? Okay. Um, we can use 16. Wait, let me choose my words carefully. Let me just run through a hypothetical in my brain. If I say that this is 60, I could say that this is, oh yeah, you could use 60. That's fine, that's fine. Yeah, so we're gonna use 60. First things first, let's label our sides. If this is angle A, or what I call this side,
It will be common A.
come on A, yeah. If this is angle K, what I call this side,
Common K.
right? And what would I call this side?
Common T.
Great. Now, let me show you. I don't know if you get the hint, but check all of the formulas before. In this formula, okay, in this formula, right? J was the what? Look at the diagram. What was J in the formula? J was the what? The side opposite the what?
The angle.
Yeah. Let's look at
Yes.
another example. A was the what? What was A in this question?
The side opposite the angle too.
Exactly. Like I think you could see our pattern here. So how do you think we're gonna write this formula out? Think about it. Think about it carefully. What's the side opposite the included angle?
A squared.
So we're gonna write A squared. And then we're gonna write the other two sides. We're gonna square them and then add them, right? So you tell me.
Okay. It will be equal K squared
Right.
plus T squared
Right.
minus
You could do this. You could do this. Wait, we'll find an appropriate meme for this occasion.
2.
Nah, yeah. This is me right now. Like I'm screaming quietly. I want you to get it correct. I want you to get it correct. Yeah. Minus 2. Yeah.
K, open brackets, K,
You don't have to put open brackets. It's fine. Okay.
T,
Right.
cosine 60.
You're not wrong, but let me leave it as A for now. All right. Dab up, they pick up you. Ah boy, that we talking about. Let's go. Right, dab up. I'm gonna assume you have enough, right? Pick up yourself. You just now got through. Okay. If you understand bearings and you understand this, tomorrow you'll be real set. Trust me, you'll be real set. Right? Because the only thing we have to look at after this is the sine rule. They're a little more complicated, I would say. Have a little more algebraic manipulation. But if you understand this, pick up yourself. So, Adika, let's start to substitute now, right? So, what is K? What is K?
K is 18
So, you can write 18 squared. What's T?
plus 19 squared.
Right. What's K?
18,
What's T?
19,
Cosine what?
cosine 60.
All right. You know how the badness will go, right? The badness will go by now. I think you could get the answer from here. So you're gonna in the Casio, I tell you, sharp not in my vocabulary. Like I just struggle to say the word sharp. I just struggle. Like my mouth is like autocorrect me sometimes. Like I want to say sharp, it's autocorrect to Casio. Things bad, things bad. Right. So if you're a Casio user, guys, all you know all you could do, right? All you have it real easy. You're just gonna plug it in the exact same way you've seen it. This is what you're gonna do if you're a Casio user. If you're a Sharp user, it's going to look like this. Open bracket 18 squared plus 19 squared minus 2, 18, 19, cos 60. Plug that into your calculator and let me know what you're getting.
18.52.
I want somebody to verify that. Somebody on the TikTok live verify that for me. Well, again 18.52.
Yeah.
Right, somebody verify that. Hey, Tavon, you there? Tavon is still here?
I see what you see.
You see my girlfriend, look, she right there. Baby, you there?
I see exactly what you do. Tell me, boy. I see exactly what you see.
My girlfriend wireless. Hello, you there? Since you're here, right? Guys, my girlfriend is very good at maths. Very, very good at maths. So, let's she verify this. Can you verify is 18.52? I don't
Verified.
Oh God, yeah, definitely. God. Okay. For those that don't know, I have like 8 speakers right now. I have a big subwoofer in the bottom, and I have like 4 speakers here. So like when I talk loud, my ears going. Like anyways, I'll get 18.52. Camille, you get 18.52.
No, come on.
I didn't work out anything.
What? Nah. Work it out fast. Come on. Right, Isabella, great job. Yeah, it's 18.52. Let me just verify that on my end. Right? Square root 18 squared. Camille, I'm gonna kind of train into the D portion, because the next question we're gonna actually do a variance question with the cosine rule in it. Yeah. I just gave you a heads up, you know. Just gave you a heads up.
Yes, that is correct. All right.
Wait, I don't know why I do. 18 squared. By the way, guys, tune in, because one of these days I'm gonna do a 48-hour live, and then I'm gonna do 72 hours live, 72-hour live. I'm gonna teach maths 48 hours straight, and then 72 hours straight. And I'm not going past that. I might die if I go past that. But like,
So you're basically doing over the same thing that you did for when you for the May June
oh God,
exams. You did all-nighters with us.
you know about that?
Yes, I was here. I got a 2 in maths, and I even pre-1.
Give my dad the big up yourself, big up yourself, big up yourself. Let's go. In for that
I
one.
was here for the physics live too.
Hey,
I got a 2 in physics.
big up yourself. Big up yourself. Nice, man. Nice, nice. But you know what I want to understand. Right? All right. So 18.52 is excellent. Great job. So, Adika, you probably come in today not understanding much, but I feel like you reach a real good place now. You know how to deal with cosine rule. Big up yourself. Yeah. A lot of students have trouble with cosine rule. I don't know why, but cosine rule is a real trouble to students. So big up yourself. Should be proud of yourself. Right? So, Adika, you have anything you want me to go through before we move on?
No, I understand everything so far.
All right. So how you feeling? I want you to tell me if you see a sticker that describe how you're feeling right now. Seen anything that describes how you're feeling right now?
Um, the one, the Indian one.
The Indian one? The Indian one?
Scroll down. The one with the thumbs up.
Oh, that's me. Oh, that's me. That's me.
Oh.
Yeah. It's a very shabby picture of me. Right?
Yeah.
Okay. All right. Cool. So, Camille, time to throw you in the ocean. Right? Time to throw you in the ocean. Let's go. Let's go. Camille, you're excited. You're ready. You're ready. You're ready. You're excited. You ready for this? You ready to drop some heat here?
Yeah, I guess.
What is with that melodramatic energy, man? Come on. Here. Mute yourself and come back with real energy.
So, again, again.
Okay.
You're not hearing the energy?
You need some Lucozade or something. You need some Monster or something. Red Bull or something. All right. I'm gonna take your word for them. So, Camille. This is a question we looked at in the past, right? We looked at this question in the past. So we were able to figure out that. Well, actually, we didn't figure out anything, right? We just put down information.
Yeah.
Okay. Camille, I'd like you to read part 3.
Calculates the length to the nearest kilometer of km.
That's kind of funny, right? Because kilometers km. Right, but anyways, one of the previous parts, they had made us 40 degrees over here. So Camille, I think you could see what they want me to find from, right? They literally want us to find for km. So what do you think we should use?
The cosine rule.
Exactly. Do we have an included angle?
Yes, we do.
Yeah, we do. What's the included angle here?
40 degrees.
Right. So let's just label our triangle appropriately, right? So this is angle, okay? What would this be?
Which one are you pointing at?
All right, if this is angle key, right?
Yeah.
What would this be?
Common key.
Right, common key. If this is angle M, what would I call this?
Common M.
M and M. Yes, I'd call this common M. And lastly, if this is angle L, what would this be?
Common L.
Right. How would the formula look like for this question?
They want us to find for L.
Right.
So
Now, remember, in all the formulas, right? Look at this. Let's try to observe something. In this question, they wanted us to find for A, right? Now, A is the side opposite the angle. So, we started off the formula with A squared, and we ended off with the included angle E. And everything in the middle was the adjacent sides. So, tell me, how should I write the formula here?
So it'll be L squared.
Mm-hmm.
Equal K squared plus M squared minus 2 open brackets K close brackets open brackets M.
You don't have a bracket,
close
eh?
brackets.
You don't have brackets, but if you put the brackets, nothing wrong with that.
Okay.
I can literally just write 2km. Right?
Close capital L.
Lovely. Next line now. Tell me what to
And
write.
then L squared equals K would be 120 squared
Right? 120 squared.
plus 80 squared minus 2 open brackets 120 close brackets open brackets 80 close brackets cos 40 degrees open brackets.
Right. What next?
And then the next line would be L
Wait,
open brackets.
before you tell me, right? I see you flipping some pages. I want you to figure these things out without looking at anything, right?
Okay.
So, Camille, we have L squared here. We are trying to find for what?
The square root.
No, we're trying to find for L, right?
Oh, right, yes.
So we have L squared. What would get rid of the squared?
That's
What's the opposite of square root in something?
square root.
Square root, yes. So you'll apply the square root on both sides. Because the square root of L squared is just L. Right, so we end up with L here. Right? Plug this into your calculator and let me know what you get. Right? Excellent job, Nicolette. Excellent job. 120 squared. you did everything correct, you should get 78.05.
Yeah, I got that.
Big up you. But any question? What did they say? Set to the nearest kilometer.
Nearest. Right, so that would be like 2 decimal place.
No, this will be okay. This will be in the 10th position, and this will be in the 1st position. Taking it back to standard 5 here. Check this, right? This will be 17 kilometers.
80.
No. This will be 8 kilometers. Right? This would be 1/10 of a kilometer. So it's going to be 78. If it was 78.5, it would be 79. If it was, say, 78.7, it would be 79. But since it's 78.05, what they're going to do is they're going to look at the ones position of the kilometers, and they're going to look at the number after it. So 0 is after 8, but we know it's less than 5. So you'll just round down. You understand? Or you're confused by that?
Yeah. No, I understand.
What if we had 95.7? What are wrong?
96.
Yep, great. So we're going to end up with 78 here. That's going to be our answer. So, Camille, you now know how to answer a 3-mark question. How you feeling? You feeling good?
Yeah, I am.
Yes. Right. So I'm gonna end the live here. Right. Do you have any questions before I go? Anything at all you want me to clear up? Anything at all? I'm here to clear up confusion. So if you're confused by anything, now is a chance. I will go over anything. All right. Darius, you still there?
Yes, sir.
All right, Darius, did you understand how we utilize the cosine rule in this question?
Yes, sir.
All right, and do you see how, look at this, right? In the first part, they wanted me to put down the 40 degrees. I put it over here. Then in part 2, they wanted me to calculate KLM, right? KLM, that would be this angle over here. And we found it was 40 degrees because, alternating angles, yeah?
Right.
Right? And if you look at the diagram now, can you see an included angle?
Yes, sir.
Yeah. And if you have an included angle, what can you use?
Cosine rule.
Yes. Right? Exactly. And we know, remember at the start, when we were starting cosine rule, I said, what did I say? And I said, well, read that for me. Read that for me. Read that for me.
Allows you to find the length of the side opposite the included angle.
You understand what I mean? What I mean by that now? 100%?
Yes, sir.
Nice. Because 40 is the included angle over there, and L is over here. And we were able to find the length opposite the included angle. Right? Guys, hopefully tomorrow I'll be able to do a live. If so, I will continue and we will do sine rule. After I do sine rule, we can just start hitting past paper questions and we'll be good for bearings. Right. So I see somebody ask me, so costs don't have to be used in just finding angles. You can use it to find distance as well. Well, Nicolette, the primary reason for the cosine rule is to find for lengths. You will rarely ever use the cosine rule to find for angle. So guys, here what I'm saying, right? The cosine rule, Okay, the cosine rule, lengths. Right, so cosine rule is mainly used to find for lengths. Now, you could use it to find for the angle, but that's going to be very cumbersome. We typically use the sine rules to find for angles. Right? So, Nicolette, I hope that clears up the confusion. So, we use the cosine rule to find for lengths. We use the sine rule. What are rules for? Right? We use the sine rule to find for angles. And lengths, you can use it to find for angles and lengths. Right. But yeah, guys, all the final live was good. All the final live was. This is my second live ever. Second.
That's good.
Well, I'm happy to hear that I was able to help you guys. And it was great meeting you all. And to my students in my class, thank you for staying till the end. Like Sheena, Ivan, Darius, big up on yourself. And it was great meeting you people like Adika, Camille, right? It's really good meeting you guys. You guys definitely learned some new stuff. So yeah, guys, have a blessed night. Merry Christmas and tune in tomorrow for Sign Rule. Later, guys. Bye.
Same time, right, sir?
So
Bye.